October 29th, 2025. While you scrolled through your phone while you sat in traffic while the world spun through another ordinary Tuesday, something the size of Manhattan reached the closest point to our sun. Hidden, completely unobservable from Earth. The timing was perfect. Too perfect. This is the exact moment a spacecraft would fire its engines to change course. Maximum efficiency. Maximum energy gain. The laws of orbital mechanics are brutally clear about this. If you want to maneuver, this is when you do it. And 3 weeks earlier, the United Nations launched a global tracking campaign. Same day, SETI updated their contact protocols for the first time in 15 years. All eyes on 3I Atlas, all systems synchronized. The question isn't whether something is happening. The question is what they're preparing for. Tonight we explore an object that exhibits 8 documented anomalies, 8 separate ways it violates our expectations for natural comets. We examine why NASA went silent during a government shutdown, but only about this object. We trace the infrastructure built around 3I Atlas before most people knew it existed. And we ask a question that should concern everyone paying attention. What if the disaster isn't an explosion but a resonance? What if we've already triggered something we don't understand? This is speculation grounded in measurement, mystery wrapped in mathematics, a story told through data that refuses to fit our comfortable explanations. The universe doesn't ask permission to be extraordinary. Sometimes it just sends postcards from the darkness between stars. This is one of those postcards, and we're still trying to read what it says. July 1st, 2025. The Atlas survey in Hawaii detects a new object. Automated telescopes scan for anything moving against the stars. This one is different. The trajectory isn't an ellipse. It's a hyperbola, an open curve that never returns. This object came from somewhere else. It's passing through our solar system once then leaving forever. An interstellar visitor, only the third we've ever confirmed. Oumuamua in 2017, that strange cigar-shaped object that sparked years of debate. 2I Borisov in 2019, which looked like a normal comet from interstellar space. And now 3I Atlas. At first glance it looks like a comet, 5 kilometers across. It has a coma, that fuzzy cloud of gas and dust. It has a tail. It's shedding material as it approaches the sun. Here's what you need to know about comets. They're essentially dirty snowballs. Ice and rock left over from planetary formation. When they get close to a star, the ice sublimates, turns directly from solid to gas. Water ice, carbon dioxide, methane, all becoming gas. That gas expands outward, creating the visible coma. It carries dust particles that reflect sunlight. The tail forms because radiation pressure and solar wind push this material away from the sun. Critical point comet tails always point away from the sun. Always. The forces push material outward, away from the star. Remember this. 3I Atlas entered at 44 kilometers per second. Fast. Spectroscopy shows the coma is dominated by carbon dioxide, not water. Only 4% water by mass. Unusual, but 2I Borisov showed similar chemistry. Maybe interstellar comets are just different. This is the baseline. Ice sublimating, dust reflecting, tail forming, standard cometary behavior. But 3I Atlas exhibits 8 separate anomalies, 8 ways it deviates from expectations. Let's explore them. July and August 2025. Telescopes around the world turn their attention to the newly discovered interstellar visitor. Among them, the Nordic Optical Telescope in the Canary Islands, a 2.5-meter mirror patiently collecting photons from an object millions of kilometers away. The astronomers see something strange. The tail is pointing the wrong direction. Remember what I said about comet tails always pointing away from the sun. This is one of the most fundamental, reliable observations in all of cometary science. Radiation pressure and solar wind are relentless forces. They push material away from the star. There's no mechanism by which dust and gas should flow toward the sun, and yet in image after image, the brightest emission from 3I Atlas forms a fan-shaped structure pointing sunward. Not a faint optical illusion, not a secondary feature. The primary, most luminous part of the tail aimed directly at the sun like an arrow. This is called an anti-tail. Now, anti-tails aren't completely unprecedented. We've seen them before on solar system comets. But here's the crucial distinction. Almost all documented anti-tails are geometric artifacts. Perspective effects. The tail is actually pointing away from the sun as it should, but Earth's viewing angle makes it appear to point sunward. Change your observation point, wait a few days for the comet to move, and the illusion resolves. The tail is where it belongs. But 3I Atlas was observed from multiple locations from different angles over multiple weeks. This wasn't a perspective effect. The structure was genuinely there, genuinely pointing sunward, genuinely contradicting the physics that should govern its behavior. David Jewett and Jane Liu, two of the world's leading experts on small solar system bodies, published their analysis of the Nordic Optical Telescope observations. Their paper is careful technical measuring the mass loss rate, tracking how the brightness changes with solar distance, confirming that carbon dioxide sublimation is the primary driver of activity. Everything in their paper suggests normal cometary behavior except for that sunward-pointing tail. How does dust move toward the sun when radiation pressure should push it away? How does gas flow toward the star when the solar wind should sweep it outward? The observations are clear. The physics don't cooperate. Several hypotheses exist for natural anti-tails. One involves the release of large ice fragments that have short lifetimes before they sublimate completely. These fragments might scatter light intensely for brief periods, creating bright features that don't follow the typical tail dynamics. As the comet moves through its orbit, if these emissions happen to align with our viewing angle toward the sun, they could create the appearance of a sunward flow. Another hypothesis involves complex particle dynamics. Different sizes of dust particles respond differently to radiation pressure. Very small particles get pushed away quickly. Very large particles hardly respond at all and simply follow the comet's gravitational path. Maybe the anti-tail represents a specific size range of particles, behaving in unexpected ways due to 3I Atlas's particular composition or rotation. These are reasonable scientific hypotheses. They might be correct. The challenge is that we're trying to explain something we've never seen before in quite this configuration with an object we can't examine closely, using observations from hundreds of millions of kilometers away. But here's where it gets stranger. In September, the anti-tail disappeared. The tail structure reoriented. By the time 3I Atlas approached perihelion, its closest point to the sun, the brightest emission was streaming away from the star, exactly as you'd expect from a normal comet.
What changed? Avi Loeb and Eric Quito from Harvard published a detailed theoretical model explaining this transition. Their analysis focuses on how different materials respond to increasing solar heating as the comet approaches the sun. At greater distances, 3 to 4 astronomical units from the sun, water ice fragments dominate the visible scattering. These ice chunks are large enough and numerous enough to be the primary thing we see when we look at the comet. But they have short resonance times. They don't last long. They sublimate quickly or break apart. As 3I Atlas gets closer, as temperature rises exponentially, the sublimation rate increases dramatically. The resonance time decreases. The ice fragments spend less time in the visible outflow before they disintegrate. Meanwhile, refractory dust particles, the rocky material that doesn't sublimate easily, those persist. They accumulate. They become the dominant scatterers at closer distances.
And dust responds to radiation pressure. Dust forms normal tails pointing away from the sun. The model is elegant. The physics is sound. It matches the observed timeline of the transition. This is what natural science looks like when it's working properly. Observations leading to theoretical models that explain anomalous data. Problem solved. Except Adam Hibbert, a colleague working with Loeb, offered an alternative interpretation that's harder to dismiss than it should be. If 3I Atlas is an engineered spacecraft attempting to slow down this transition from anti-tail to normal tail near perihelion, would represent exactly what you'd expect from a shift between braking thrust and forward propulsion. Read that again slowly. A spacecraft entering a star system at high velocity would need to shed speed if it wanted to stay, if it wanted to capture into orbit, rather than pass through and leave. The most efficient way to slow down is to fire your engines opposite to your direction of motion. That's called a retrograde burn. Your exhaust plume would stream forward in the direction you're traveling, which happens to be roughly toward the sun as you approach perihelion. From Earth, that would look like an anti-tail. Then once you've shed enough velocity, you might switch to a different configuration. Maybe a gravitational assist maneuver, maybe positioning for later operations. Your engine exhaust changes direction. Now it's pointing backward away from the sun. From Earth, that would look like a normal tail. This is speculation. This is explicitly labeled speculation. The natural explanation from Loeb and Quito is almost certainly correct. Ice sublimation dynamics are sufficient to explain what we observed. But the alternative interpretation exists. It fits the data, it matches the timeline. And it's unsettling precisely because we can't definitively rule it out without more information than we currently possess. This is the pattern that repeats throughout the 3I Atlas story. Every anomaly has a natural explanation. Every strange observation can be accounted for by unusual but possible cometry processes. But every anomaly also has an alternative interpretation that suggests something more deliberate, more intentional, more engineered. Neither interpretation is proven. Both remain possible. The data doesn't exclude either one. That's the most frustrating thing about this mystery. We're not dealing with definitive proof of anything extraordinary. We're dealing with ambiguity, with multiple explanations that both fit the observations, with uncertainty that persists despite our best efforts to resolve it. The anti-tail appeared, then disappeared. The timing of that transition aligned perfectly with perihelion passage, and we're left wondering whether we witnessed exotic ice dynamics or an engine configuration change. The universe, as usual, declines to answer clearly. October 21st, 2025. The sun, as viewed from Earth, moves across the background stars throughout the year. On this date, from our perspective, the sun passes directly between Earth and 3I Atlas. This is called solar conjunction. For 8 days from October 21st through October 29th, Earth Atlas is hidden behind the sun. No ground-based telescope can observe it. You can't point a telescope at something that's behind the brightest object in the sky. The sun's glare drowns out everything nearby. Earth-orbiting spacecraft can't see it either. Most are positioned to observe outward, away from the sun. The few that look sunward like solar monitoring satellites aren't designed for distant object tracking. For 8 days, 3I Atlas operates in perfect privacy. Whatever happens during that window happens without witnesses. October 29th, still hidden behind the sun. 3I Atlas reaches perihelion, its closest approach to our star, just over 200 million kilometers closer than Earth's orbit, farther than Venus. At this distance, solar radiation delivers 33 gigawatts of power to an object 5 kilometers across. That's the output of 30 nuclear reactors focused on a single target. For a comet, that energy drives sublimation. Ice turns to gas. Activity increases. The coma brightens. The tail extends. This is what makes perihelion passages so spectacular for natural comets. Maximum solar heating produces maximum activity. But perihelion means something else for spacecraft. Something crucial. The Oberth effect. This is named after Hermann Oberth, one of the founding fathers of rocketry who understood something counterintuitive about orbital mechanics. The best time to burn your engines isn't when you're moving slowly. It's when you're moving fast. It's when you're deep in a gravity well. It's when your orbital velocity is at maximum. At perihelion, 3I Atlas is moving at 68 kilometers per second. The gravitational acceleration from the sun has boosted it to peak velocity. If you fire engines at this moment, every gram of propellant, every meter per second of velocity change translates into maximum kinetic energy transfer. The mathematics is brutal in its clarity. Energy gain scales with your velocity at the moment of thrust. Double your speed, double the efficiency. Triple your speed, triple the gain. If you're going to perform a major maneuver, if you're going to change course, shed velocity, capture into orbit, perihelion, is when you do it. This isn't speculation. This is fundamental orbital mechanics. This is how every spacecraft mission to the outer solar system is designed. This is why probes use gravitational assists, diving close to planets to maximize efficiency. And this optimal window occurred while 3I Atlas was hidden, completely unobservable from Earth. Is this a coincidence? Avi Loeb has calculated the probability. He's assigned numbers to the statistical likelihood of various aspects of 3I Atlas's trajectory. The mathematics is peer-reviewed, published, available for anyone to check. The probability of an interstellar object arriving on a trajectory that brings it close to multiple planets in our solar system, 0.005%. 5 chances in 100,000. Most interstellar objects would pass through the outer solar system, staying far from the sun, far from major bodies, too faint and too fast for us to detect. The ones we do see are selected by observation bias. They come close enough and bright enough for our telescopes to spot them. But that doesn't fully explain the timing. 3I Atlas's perihelion passage occurs during solar conjunction. The optimal maneuver window happens when Earth-based observation is impossible. That's independent of planetary encounter timing. That's about where Earth is in its orbit relative to the object in the sun. Having those two things align, optimal engineering window, coinciding with observational blind spot, that adds another layer of improbability. If you were designing a mission to an alien star system, if you wanted to perform operations without being observed by the inhabitants of the third planet, this is exactly when you do it. Hidden behind their star, moving at maximum velocity, positioned for optimal gravitational assist. Let me be clear, this doesn't prove artificial origin. Coincidences happen. Unlikely events occur regularly. Someone wins the lottery, someone gets struck by lightning, someone flips heads 20 times in a row. Low probability doesn't mean impossible, but it does mean we should pay attention. It does mean this deserves scrutiny. It does mean dismissing the pattern as random chance requires being comfortable with a chain of improbable alignments.
The trajectory brings 3I Atlas within observational range of Mars on October 3rd, about 30 million kilometers away. The Mars Reconnaissance Orbiter is perfectly positioned. Its high-rise camera, capable of resolving objects down to 30 centimeters from Martian orbit, has a clear line of sight. This is the closest any human-made instrument gets to 3I Atlas during its entire passage through the inner solar system. The shot. The opportunity to see surface features, to measure dimensions precisely, to capture data that could resolve questions about composition and structure. And NASA is closed. Government shutdown. We'll return to that particular mystery soon. The trajectory continues. Venus at closer range than usual. Jupiter encounter scheduled for March 2026. Multiple opportunities for observation. Multiple planetary bodies providing gravitational reference points for tracking the object's motion.
And there's one more element to the timing that's harder to quantify, but equally unsettling. 3I Atlas's trajectory, traced backward through interstellar space, points toward a region of sky within 9 degrees of where the famous WOW signal originated. That radio signal detected on August 15, 1977. 72 seconds of strong, narrow-band emission that's never been explained, never been repeated, never been identified with any known astronomical source. The signal came from the direction of Sagittarius, from the general region toward the galactic center, from an area dense with stars. Jerry Eman, the astronomer who found it in the data, wrote, Wow in the margin because it was so strong, so clear, so exactly what you'd expect from an artificial transmission, and then silence. Decades of follow-up observations. Nothing. The signal never appeared. Again. 3i Atlas comes from almost the same direction. 9 degrees away. That's close on cosmic scales. Close enough to wonder. If the WOW signal was a transmission from a probe, if that probe was 3i Atlas, if it announced its arrival and then went silent, the geometry works. The timing doesn't. Not quite. 48 years between signal and arrival. But if the probe was still far out when it transmitted, if it announced itself early as it entered the Oort cloud, maybe the numbers align. This is pure speculation. I'm labeling it clearly. The WOW signal has numerous proposed explanations, several of them natural. And 9 degrees is close, but not identical. Not a perfect match. The probability of random alignment within 9 degrees, about 0.6%, 6 in 1,000. Unlikely, but not extraordinary. Still, it's another piece of the pattern, another element that makes you pause, another data point that doesn't prove anything but refuses to be dismissed comfortably. October 29th came and went. 3i Atlas reached perihelion and continued on its trajectory. From our perspective, from Earth's vantage, nothing dramatic happened. No explosions, no visible maneuvers, no obvious signs of artificial activity. But we weren't watching. We couldn't watch. The object remained hidden behind the sun, and we remained ignorant of what, if anything, transpired during those critical hours. Absence of evidence is not evidence of absence. We didn't see nothing happen. We saw nothing, period. And in that blindness, in that gap, in observation, possibilities multiplied, questions accumulated, doubt flourished. The truth is somewhere in the data we don't have yet, in trajectory measurements that will be made in coming weeks, in observations that spacecraft will capture, in analysis happening behind closed doors. The truth is being determined right now. We're just waiting for someone to tell us what they found, or what they're willing to say they found. October 1st, 2025, the U.S. government runs out of money. 15,000 NASA employees receive furlough notices. The space agency officially closes, except it doesn't. Not really. Not when it matters. October 3rd, 3i Atlas makes its closest approach to Mars. The Mars Reconnaissance Orbiter is perfectly positioned. Its high-rise camera can resolve objects down to 30 centimeters from Martian orbit. This is the shot, the closest any human-made instrument will get to occur 3i Atlas during its entire passage. And NASA is closed. The Daily Mail caught them in the contradiction. When asked about 3i Atlas observations, NASA said the entire space program is closed due to the shutdown. But here's what the Daily Mail noticed. If they're closed down, why are they putting out selective news like the quasi-mini-moon announcement? Seems a bit selective to me. During the same shutdown that prevented NASA from commenting on 3i Atlas, they released a full press package about a mini-moon. Interesting, sure, but hardly urgent. This is selective silence. You don't shut down completely, that would be suspicious. You release information that's safe, mundane. You sit on information that's problematic. The high-rise images exist. The spacecraft executed its observations. The data was collected and downlinked. They're sitting on servers somewhere. But NASA can't release them yet, because releasing them requires decisions about what they show. If they're boring, release is easy. If they show something unexpected, release becomes complicated, requires consultation, coordination, messaging. The shutdown provides perfect cover. China's silence is more suspicious. Tianwen-1 was also positioned to observe. China has released over 14,000 Mars images. They're aggressive about demonstrating capabilities. Yet 3 weeks after the flyby, not a single image of 3i Atlas. Not even acknowledgement they attempted observation. If this were ordinary, China would have released pictures immediately to upstage NASA. The fact they haven't suggests something requiring coordination. ESA released images limited, carefully selected, a fuzzy white dot. Nothing remarkable. Safe images, but ExoMars has other instruments, spectrometers, infrared sensors. Why didn't ESA release that data? Because the camera image is safe. It shows nothing controversial. This is the playbook. You appear transparent while controlling what gets released. You use legitimate excuses, shutdowns, technical limitations, processing delays to explain why interesting data isn't available yet. The longer the delay continues, the more suspicious it looks. Every day suggests the images are problematic. Show something unexpected, require careful handling. The data exists. The truth is recorded. We just don't have access to it yet. And every day of delay whispers that access is being controlled for reasons beyond budget shortfalls.
September 30th, 2025. A white paper lands on the desk of the United Nations Office for Outer Space Affairs. The authors are Avi Loeb, Amir Dardi, and Gersian Tenem. The document advocates for coordinating global scientific research, maximizing observational coverage, ensuring optimal monitoring of interstellar objects like 3I Atlas. Objects that could, the paper notes, carefully pose a threat to humanity if they happen to carry alien technology. Black swan events with small probabilities must be considered seriously if their implications are large. That's the language. That's the framing. 3 weeks later, October 21st, the International Asteroid Warning Network makes an announcement. They're initiating a campaign to monitor 3I Atlas, a training exercise they call it. Planetary defense. The dates are specific. November 27th, 2025 through January 27th, 2026, right through the window when 3I Atlas emerges from behind the sun, when it becomes observable again.
When any unusual activity, any trajectory changes, any deployed objects would become visible to Earth-based telescopes. Same day, October 21st. The Minor Planet Center issues an editorial notice. Comets present unique challenges for accurate astrometric measurements and orbit predictions. The notice is dry, technical, bureaucratic, but the timing. Always the timing. And here's where it gets interesting. That same September, just before Loeb's white paper, CT releases something they've been working on for 15 years. A revision of their post-detection protocols. The rules for what happens when we detect extraterrestrial intelligence. Who gets to communicate? Who gets to know? Who controls the message? The document is titled SETI Post-Detection Protocols Progress Towards a New Version. The lead author is Michael Michaud. The framework effectively centralizes post-detection communication authority to a narrow circle of authorized scientists, government agencies, and international bodies. Read that again. A narrow circle. Authorized. The revision restricts who can speak, who can share, who can tell the world that we are not alone. Now, on paper, these are separate projects. The SETI protocols have been in development for years. The IRWN campaign is a legitimate planetary defense exercise. Loeb's white paper is academic advocacy. 3 unrelated initiatives from 3 separate organizations, all happening to converge in the same month around the same object. But let's think about what's actually being built here. SETI creates the reporting policy. They define what constitutes a detection, what evidence is sufficient, what channels must be used. ON runs the observational campaign. They coordinate the telescopes, the data collection, the measurements. They determine what gets flagged as anomalous. And UNUSA, the United Nations Office for Outer Space Affairs, sits at the apex of both structures, the only place where every national space agency already has a seat at the table. If you wanted to build a system to control information about an extraterrestrial object, this is exactly what you'd build. A pipeline. Data flows up from telescopes around the world. It gets filtered through IAWN's coordination network, processed according to SETI's protocols, reviewed by UNUSA's International Committee. And only then, only after passing through every layer of institutional review, does information reach the public. The beauty of it from a control perspective is that every step looks legitimate. Planetary defense is necessary. We need systems to track dangerous objects. Post-detection protocols are prudent. We need frameworks for first contact scenarios. International coordination is essential. Space is a global commons. No one can argue with any of that. But when you layer them together, when you synchronize their deployment around a specific object, you create something else entirely. You create a choke point, a single pipeline through which all information must flow. And here's the thing that should make everyone pause. This infrastructure appeared before 3i Atlas did anything obviously unusual. The white paper was submitted when the object was still 4 astronomical units from the Sun, before the anti-tail reversed, before perihelion, before any of the timing coincidences that would later fuel speculation about artificial origin. They built the information control system in anticipation of needing it. Think about that. Either they saw something in the data that hasn't been made public, something that justified building this framework before the object became headline news, or they're running a drill, testing the system's capabilities, using 3i Atlas as a convenient test case. Both possibilities are fascinating. Both raise questions that aren't being addressed in official channels. The social media post that brought this to wide attention framed it perfectly. When I kept speaking about a blanketed silence, this is what I was talking about. If every anomaly has to be reported through the same UN-approved channel, then whoever runs that pipeline decides what's real, what's rumor, and what the public ever hears about. Call it planetary defense, and nobody bats an eyelid. You can build a global sensor grid sync, every major telescope monitor the skies 24/7 without ever saying the scary word UFO, and there's the tell, the language. Planetary defense money is automatic. No need for hearings, no headlines. The same infrastructure safer branding. You want funding for a global telescope network to search for alien technology. Good luck with that congressional hearing. You want funding for planetary defense against potentially hazardous asteroids. Here's your budget. Here's your mandate. Here's your international coordination framework. Same hardware, same sensors, same data streams, different label. But the infrastructure does more than just observe. These drills, these campaigns, these protocols, they test us, the public. They test information flow. How fast does a story spread? Who questions it? Which outlets copy-paste the official language? That's a stress test for narrative management, not just asteroid tracking. This is sophisticated. This is what information control looks like in the modern age. You don't suppress the story. You don't classify everything and hope it stays buried. That doesn't work anymore. Too many independent telescopes, too many amateur astronomers, too many people watching the sky. Instead, you build legitimate-looking institutions. You create official channels. You establish protocols and procedures and review boards. And then you make sure all information flows through those channels. You become the authoritative source, the place journalists call for comment, the database where measurements get logged, the committee that determines what's anomalous and what's normal. And if something genuinely unusual happens, if 3i Atlas performs a maneuver or deploys objects, or does anything that can't be explained as natural cometary activity, that information enters your pipeline. It gets reviewed by your committees. It gets contextualized according to your protocols. And by the time it reaches the public, it's been shaped, framed, managed, the rough edges smoothed, the implications carefully worded, the narrative controlled, unless of course something happens that's too obvious to contain, too visible, too many witnesses. That's the nightmare scenario for any information control system, the event that bypasses the pipeline entirely. And that's why the timing of this campaign matters so much. November 27th through January 27th. right when 3I Atlas emerges from solar conjunction, right when amateur astronomers can point their telescopes at it again, right when any post-perihelion activity would become visible. The IAWN campaign ensures that during this critical window, there's a coordinated global observation network already in place, already collecting data, already feeding information up through official channels. If something unusual appears in the sky, if backyard telescopes start picking up objects that weren't there before, the official network will see it too. Probably see it first, given their resources. And that means the official narrative gets established before the speculation takes over. It's actually brilliant in a Machiavellian sort of way. You're not suppressing information. You're not even really hiding anything.
You're just making sure that when people look for authoritative information, when journalists need expert quotes, when the public wants to know what's really happening, they come to you. They trust your data. They accept your framing because you're the International Asteroid Warning Network. You're the United Nations Office for Outer Space Affairs. You're SETI, the organization that's been searching for extraterrestrial intelligence for decades. Who else would you trust? And maybe this is all exactly what it appears to be. Responsible scientific institutions doing responsible things, building frameworks for scenarios that are unlikely but not impossible, coordinating observations of a rare and interesting object, testing their systems so they'll work properly if something genuinely dangerous appears. Maybe the timing is coincidence. Maybe the synchronization is just bureaucratic efficiency. Different organizations happening to act on the same problem at the same time.
But there's another layer here that deserves attention, the psychological dimension. These drills, these campaigns, these protocols, they do something beyond their stated purpose. They normalize the idea of global coordination around potentially threatening objects from space. They establish in the public mind that this is something governments and international bodies take seriously. That there are systems in place, that someone is watching, that we're prepared. And if you're preparing the world for potential disclosure, for the possibility that we're not alone, that we're being visited, that there are technologies in our solar system we didn't build, this is how you do it. Not with a press conference, not with a dramatic announcement. You do it slowly, gradually. You build the infrastructure first, establish the institutions. Create the protocols, run the drills. Get people used to the idea that space agencies are tracking unusual objects, that international cooperation is necessary, that sometimes things happen that require careful management and coordination. Then, when the actual event occurs, when something undeniable appears, you're not starting from scratch. You're not trying to build trust and establish authority in the middle of a crisis. You've already done that work. The systems are in place. The public knows who to listen to. The narrative framework already exists. But they're not preparing us for disclosure. They're preparing to manage it. That's the key distinction. The information will come out one way or another. Too many eyes on the sky. Too much data being collected by independent researchers. Too many amateur astronomers with too much equipment. But managing how that information spreads, how it's interpreted, what conclusions people draw, that's achievable. That's what this infrastructure enables. The original analysis ends with an assessment that's hard to disagree with. Keep an eye on this situation because, frankly, it stinks. Not because there's smoking gun evidence of conspiracy or cover-up, but because the pattern is there, the timing is there, the coordination is there. And the implications, if you follow them through to their logical conclusion, are extraordinary. We're not just watching an object anymore. We're watching the machinery of information control in real time as it processes something genuinely unknown. November and December will tell us a lot. Not just about 3I Atlas itself, about what it does or doesn't do as it emerges from behind the sun, but about how the system operates, how information flows through these channels, how quickly official statements appear, how the narrative gets shaped. The pipeline is operational. The infrastructure is in place. The data will flow. and we'll see whether it flows freely or whether it gets filtered, processed, and managed before it reaches those of us asking questions. Let's talk about what makes 3i Atlas different. Not speculation, not interpretation, just the measurements, the documented observations, the things that can be checked and verified by anyone with access to the data. 8 specific ways this object deviates from what we'd expect from a random interstellar visitor. 8 anomalies that individually are unlikely but not impossible. 8 data points that together paint a picture complex enough to warrant serious attention. Anomaly. 1. Ecliptic alignment. 3i Atlas's trajectory lies within 5 degrees of the ecliptic plane. That's the flat disk where planets orbit, where most solar system objects concentrate, where gravity and angular momentum from the original protoplanetary disk left their mark billions of years ago. Objects born in our solar system tend to orbit near this plane. Makes sense. They formed from material that was already flattened into a disk. But 3i Atlas didn't form here. It came from interstellar space, from some other stellar system where the ecliptic plane would be oriented completely differently. There's no reason for an interstellar object to arrive aligned with our ecliptic. No physical mechanism that would preferentially send objects toward us along that particular orientation. Random arrivals should come from random directions, uniformly distributed across the celestial sphere. The probability of random alignment within 5 degrees, about 2%. 2 chances in 1,000. Not impossible, not even incredibly rare, but unusual enough to notice. Unusual enough that if you saw 10 interstellar objects and one was aligned with the ecliptic, you'd wonder why that one. What makes it different? Whether there's a reason it came from that direction. Anomaly 2. The anti-tail. We've discussed this, the sunward-pointing plume that appeared in early observations, the structure that didn't match normal cometary tails. Yes, anti-tails happen. Yes, they're usually geometric illusions, but this one wasn't. This one was real material genuinely moving toward the sun against radiation pressure, against solar wind, against the forces that should push everything outward. Multiple telescopes confirmed it. Different viewing angles showed the same structure. It wasn't perspective. It wasn't an artifact. It was actual dust and gas moving in the wrong direction. That requires explanation. Natural explanations exist: unusual sublimation dynamics, ice fragment behavior, complex interactions between different particle sizes, and radiation pressure. But it's still anomalous, still something we haven't seen before in quite this configuration. Anomaly 3. The timing. The arrival schedule that brings 3i Atlas close to multiple planets while keeping it unobservable from Earth during perihelion. Mars approach in October, Venus within range, Jupiter encounter in March, and perihelion occurring during solar conjunction when ground-based telescopes can't see it. The probability of this timing, 0.005%. 5 in 100,000. You could argue this is selection bias. We only notice interstellar objects that come close to planets because those are the ones bright enough to detect. Objects passing through the outer solar system staying far from major bodies, we'd never see those. They'd be too dim, too fast gone before we knew they were there. Fair point, but it doesn't fully explain why perihelion occurs during solar conjunction. That's independent of planetary positions. That's about Earth's location relative to the object and the sun. Having the optimal maneuver window occur when you can't be observed from Earth, that's convenient. Suspiciously convenient. Anomaly 4. The chemistry, nickel to iron ratios that resemble industrial alloys more than natural minerals.
Nickel to cyanide ratios orders of magnitude higher than any known comet, including 2I Borisov. This is the signature that originally caught attention, the thing that made researchers look twice at spectroscopic data. Iron and nickel usually appear together. They're formed together in stellar nuclear synthesis. They behave similarly in planet formation processes. They condense from the solar nebula at similar temperatures. You expect them in roughly solar proportions, maybe with some variation depending on formation conditions. But 3C Atlas shows lots of nickel minimal iron. That's backwards. That's not what natural fractionation usually produces. Industrial alloys, however, are different. We make nickel steel. We purify nickel for specific applications. We create materials with whatever ratios serve our engineering needs.
If you saw a chunk of satellite debris or a piece of failed spacecraft or material from industrial processes, you might see exactly this kind of nickel without iron signature. That doesn't prove 3I Atlas is artificial, but it's another data point that doesn't quite fit natural expectations. Anomaly. 5. Low water content. Only 4% water by mass in the observed emissions. Most comets are much higher. Water ice is the primary component, the thing that makes comets comets, the volatile that sublimates and carries dust and creates the coma and tail. Comets are often described as dirty snowballs, more ice than rock, more water than anything else. But 3I Atlas is different, mostly carbon dioxide, some water but not dominant, more like a rock with surface ices than an ice ball with embedded rock. That could be legitimate interstellar diversity. Different formation conditions in another stellar system, colder molecular cloud, different chemistry. We've only seen 3 interstellar objects. Small sample. Maybe low-water comets are common out there. Or maybe the bulk composition is rock or metal, and what we're seeing is just surface condensation. Ices that accumulated during millions of years in interstellar space. A coating rather than the main body. 4 centimeters of ablation wouldn't tell us what's underneath, wouldn't reveal whether the interior is ice or something else entirely. Anomaly. 6. Extreme negative polarization. Light scattered from 3I Atlas shows polarization properties unprecedented among known comets. Polarization measures how light waves are oriented, whether they vibrate in particular directions or randomly. When light bounces off particles, it gets polarized. The degree and direction of polarization depends on particle size, composition, shape. 3I Atlas produces negative polarization beyond what's been measured for any comet, including 2I Borisov. That means the particles in its coma have unusual properties, unusual sizes or compositions or shapes. Something about the dust doesn't match what we see in normal cometary dust. The probability of this particular polarization signature estimated below 1%. Less than 1 in 100 comets would show this. Again, small sample size. Maybe we just haven't seen enough comets to know the full range of natural variation. Maybe interstellar comets are systematically different from solar system comets. Maybe formation in different stellar environments produces dust with different properties. All possible, all reasonable, but still anomalous. Still something requiring explanation. Anomaly. 7. The WOW signal. Alignment. 3I Atlas's trajectory traced backwards points toward a region of sky within 9 degrees of where the famous WOW signal originated. That radio signal detected on August 15, 1977.
72 seconds of strong, narrow band emission that's never been explained, never been repeated, never been identified with any known astronomical source. The signal came from the direction of Sagittarius, from the general region toward the galactic center, from an area dense with stars. 3I Atlas comes from almost the same direction, 9 degrees away. That's close on astronomical scales. Close enough that you could imagine a connection. If the WOW signal was a transmission from a probe, if that probe was 3I Atlas, if it announced its arrival and then went silent, the geometry works. The timing doesn't. Not quite. 48 years between signal and arrival. But if the probe was still far out when it transmitted, if it announced itself early as it entered the solar system, maybe the numbers align. This is pure speculation. The WOW signal has numerous proposed explanations, including several natural ones. And 9 degrees is close, but not identical. Not a perfect match.
The probability of random alignment within 9 degrees about 0.6%, 6 in 1,000. Unlikely, but not extraordinary. Still, it's another piece of the pattern. Another thing that makes you wonder. Anomaly 8. The velocity and trajectory. Combined. 3I Atlas entered the inner solar system at 44 kilometers per second, faster than Oumuamua, faster than 2I Borisov, moving with significant excess velocity relative to the local stellar rest frame. That speed combined with the ecliptic alignment, combined with the planetary encounter timing, creates a specific arrival configuration with very low probability when you multiply all the factors together. Each individual element is possible. Fast interstellar objects exist. Ecliptic alignments happen. Planetary encounters occur, but getting all of them together in one object, that's the statistical challenge. That's what pushes the probability low enough to demand explanation. Because while any single weird thing can be chance, 8 weird things starts looking like pattern. This is Avi Loeb's point with his scale. He's not claiming 3I Atlas is artificial. He's claiming it scores high enough on improbability that we should take the artificial hypothesis seriously, should investigate it properly, should gather all the data we can before the object leaves the solar system and the opportunity is lost forever. That's a reasonable position. That's what responsible science looks like when confronted with something unusual. The counterargument is equally reasonable. 8 anomalies sounds like a lot, but we've only studied 3 interstellar objects in detail. Sample size of 3. We have no idea what normal looks like for interstellar populations. We're comparing 3I Atlas to solar system comets. But maybe that comparison is invalid. Maybe interstellar objects are systematically different. Maybe what seems anomalous to us is actually typical out there. Furthermore, we're subject to observation biases. We detect the objects that are big enough, bright enough, close enough to see. We're sampling a tiny fraction of interstellar visitors. The vast majority pass through undetected, so the ones we do see might not be representative, might be selected exactly for having unusual properties that make them detectable. All of this is true. All of it urges caution about over-interpreting limited data, but it doesn't eliminate the fact that 3I Atlas is unusual, doesn't erase the 8 measured anomalies, doesn't change the statistical improbabilities. It just provides context, reminds us that unusual doesn't automatically mean artificial, that we need extraordinary evidence before accepting extraordinary claims. Rank 4 on a 10-point scale. That's where Loeb places 3I Atlas, 4 out of 10, less than half, not even close to definitive, but high enough to warrant attention. High enough that dismissing it as obviously natural seems premature. High enough that the hypothesis of possible technological origin deserves investigation rather than ridicule. The scale is designed to be objective. Each anomaly gets assigned a probability. Those probabilities get combined. The result is a quantitative score, not a subjective judgment. You can disagree with specific probability estimates. You can argue that certain anomalies shouldn't count. You can propose different statistical frameworks, but you can't dismiss the exercise as unscientific. It's explicitly scientific. It's attempting to quantify how unusual this object is relative to expectations. And the answer is pretty unusual. Not unprecedented, not impossible to explain naturally, but unusual enough that we should be paying attention. Unusual enough that gathering more data is worthwhile. Unusual enough that when spacecraft have opportunities to observe 3I Atlas, those observations should be prioritized. And that's happening. JUICE dedicated resources to observe it. Europa Clipper's trajectory intersects its ion tail. Ground-based campaigns are coordinated across multiple continents. The IAW training exercise focuses on it. Resources are being allocated. Attention is being paid. The scientific community, despite public statements downplaying artificial hypotheses, is treating 3I Atlas as important. Their actions speak louder than press releases. When missions get retasked, when observation campaigns get organized, when papers get published, analyzing every detail that reveals the true assessment, this object matters. These anomalies matter. The 8 data points that pushed it to rank 4 on the Loeb scale matter enough that people are dedicating careers and resources to understanding them. Whether that understanding ultimately confirms the natural explanation or reveals something more extraordinary, we'll find out. The data keeps accumulating. The measurements keep getting refined. The picture keeps coming into focus. And with each new observation, with each additional data point, the probabilities shift. The anomalies either get explained or get reinforced. The score either drops or climbs. Right now, it's 4 out of 10. That's where we stand. That's what the measurements tell us. 8 anomalies, 8 improbabilities, 8 reasons to keep watching this object carefully as it passes through our neighborhood and returns to the darkness between stars. Let's be clear about probabilities and prior assumptions. We've seen thousands upon thousands of comets. We've never seen alien spacecraft. The natural explanation should always be preferred unless evidence definitively rules it out. This is Bayesian reasoning. This is how science progresses when faced with ambiguous data. So let's build the case for 3I Atlas being exactly what it appears to be. At first glance, a comet. An unusual comet, yes. A comet that challenges some of our assumptions, absolutely, but a comet nonetheless. Start with sample size. We've confirmed 3 interstellar objects. 3. That's not a population. That's not even a representative sample. That's barely enough to establish that interstellar visitors exist at all. Oumuamua was strange, tumbling, elongated, showing non-gravitational acceleration. It didn't look like our comets. It behaved differently. And yet most scientists concluded it was natural, probably a nitrogen ice fragment from a Pluto-like world orbiting another star. 2I Borisov looked completely normal. Carbon monoxide dominated. Water present. Dust properties matching solar system comets. It was reassuringly ordinary proof that at least some interstellar visitors behave exactly as expected. And now 3I Atlas, different from both predecessors, different from solar system comets in specific ways. But is that surprising? Should we expect interstellar objects to be uniform? Think about the diversity in our own solar system. Jupiter's moon. Europa has a subsurface ocean. Saturn's moon. Titan has liquid methane lakes. Mars has water ice and carbon dioxide ice. Earth has, well, everything. And all of these formed from the same protoplanetary disk, around the same star under relatively similar conditions. Now imagine comets forming around different stars. Red dwarfs that burn for trillions of years. Blue giants that live fast and die young. Binary star systems where gravitational dynamics are completely different. Planetary systems with hot Jupiters, with super-Earths, with configurations nothing like our own. The molecular clouds where stars form have different compositions depending on their location in the galaxy. Different metallicity. Different abundances of heavy elements, different temperatures and densities. A comet forming in one of these alien environments wouldn't necessarily look like our comets, wouldn't necessarily have the same ice ratios, the same dust properties, the same behavior when approaching a star. We have no baseline for normal interstellar comet behavior. We're extrapolating from 3 data points and acting surprised when they're all different from each other. That's not scientific caution, that's just insufficient data. Now let's address the specific anomalies. The anti-tail Avi Loeb and Eric Keto published a detailed model explaining the transition from anti-tail to normal tail. Their physics is sound, their mathematics checks out. Let me walk through it. At greater distances from the Sun, 3 to 4 astronomical units, water ice fragments dominate the visible scattering signal. These chunks are relatively large. They reflect sunlight efficiently. They're what we see when we look at the comet. But they have short resonance times. They don't last long in the outflow, solar heating sublimating them. Collisions breaking them apart, they're transient. As 3I Atlas approaches the Sun, temperature increases exponentially. Small changes in distance produce large changes in temperature. Temperature changes produce even larger changes in sublimation rate. This is nonlinear physics. This is why comets brighten dramatically as they approach perihelion. The ice sublimation rate doesn't increase steadily, it explodes. When sublimation rate increases, resonance time decreases. The ice fragments spend less time visible before they disappear entirely. Meanwhile, refractory dust particles persist. These are rocky grains, silicates, organics, material that doesn't sublimate at temperatures that vaporize ice. They accumulate in the outflow. At closer distances, they become the dominant scatterers, and dust responds to radiation pressure differently than ice. Dust particles are smaller, have different shapes, different optical properties. They form normal tails pointing away from the sun. The model predicts the transition should occur around the distance where 3I Atlas was observed to change. The timeline matches. The physics is well understood. This isn't speculation. This is applying known thermodynamics and radiative transfer theory to explain unusual observations. Could the anti-tail represent something else? Sure, but when you have a natural explanation that fits the data, that uses established physics, that makes testable predictions, you don't abandon it just because an artificial hypothesis also fits. The chemistry. Yes, the nickel-to-iron ratio is unusual. Yes, it resembles some industrial alloys, but unusual and artificial aren't synonyms. Spectroscopy from Earth is hard. You're analyzing light that's traveled hundreds of millions of kilometers. You're working with faint signals. You're looking through Earth's atmosphere, which absorbs certain wavelengths. You're seeing emission from a coma, a cloud of gas and dust, not from the nucleus itself. The material we're observing represents whatever happens to be sublimating from the surface at the moment of observation. It doesn't necessarily reflect bulk composition. If 3I Atlas formed in a molecular cloud with different chemistry than our solar system, if it incorporated material from a supernova with unusual nucleosynthesis products, if it experienced processes during billions of years in interstellar space that altered surface composition, we might see exactly this kind of anomalous ratio. And let's talk about 2I Borisov for comparison. That comet showed carbon monoxide and water in ratios consistent with formation in the outer regions of another planetary system. It looked normal because it probably formed in conditions similar to our Kuiper belt, but not all planetary systems look like ours. Not all comets form in the cold outer regions. Some might form closer to their stars where temperatures and chemistry are different. Some might get scattered into interstellar space from unusual locations. We're trying to understand the diversity of an entire galaxy's worth of planetary formation processes based on 3 objects. That's like trying to understand Earth's biodiversity by examining 3 species. The timing. This is trickier. The statistical improbability is real. The alignment with ecliptic, the planetary encounters the perihelion during solar conjunction. These probabilities do multiply into something unlikely. But unlikely things happen. Someone wins the lottery every week despite astronomical odds. Someone gets struck by lightning twice. Someone flips heads 20 times in a row. When you have billions of interstellar objects passing through billions of star systems over billions of years, even events with 0.005% probability happen regularly somewhere sometime. We just happen to be the observers who saw this one. That feels significant to us. It feels like we must be special, like this must mean something. But from the universe's perspective, unlikely coincidences are happening constantly. We only notice the ones that happen to us. This is called the anthropic principle applied to astronomical observations. We're selected to observe unusual events because only unusual events get our attention. Ordinary interstellar visitors pass through unnoticed. The low water content carbon dioxide-dominated comets aren't unprecedented. Comet Encke in our solar system has low water content. Comet Schwarzmann-Wachmann orbits between Jupiter and Saturn and is driven by carbon monoxide sublimation, not water. Cometary diversity is real. We're learning that typical comets are more variable than we thought. An interstellar comet dominated by carbon dioxide isn't shocking. It might even be expected if it formed in a colder environment than our solar system's comets, or if it incorporated more ices from the interstellar medium during its journey. The polarization. Negative polarization is unusual, but unusual optical properties can result from unusual particle compositions or shapes.
If the dust in 3I Atlas's coma has different refractive indices than typical cometary dust, if the particles have different size distributions, if they're aggregates with unusual structures, we'd see exactly this kind of anomalous polarization. This tells us something interesting about the object's composition. It doesn't tell us it's artificial. The wow signal alignment. This is the weakest anomaly statistically. 9 degrees is not a close match. The probability is low, but not extraordinarily low, and the wow signal itself has never been confirmed as artificial. The most recent research suggests it might have been caused by a natural astrophysical maser, a cosmic radio amplifier created by clouds of hydrogen, or by a passing satellite, or by any number of terrestrial or natural cosmic sources. Building a hypothesis that connects two unexplained phenomena doesn't explain either one. It just creates a more complex mystery.
The velocity 44 kilometers per second is fast, but it's within the range of velocities we'd expect for objects ejected from other planetary systems. Some stars in our galactic neighborhood have high relative velocities. Objects ejected from their systems would inherit those velocities, plus whatever boost they got from the ejection process itself. There's nothing about the speed that requires artificial origin. Here's the bottom line. Every anomaly has a natural explanation. Some explanations are better than others. Some require more assumptions, but all are possible. All are consistent with known physics. All invoke processes we've observed elsewhere, just in unusual combinations. Occam's razor, the principle that simpler explanations are preferable, strongly favors the natural hypothesis. Adding artificial origin requires adding an entirely new class of phenomena, interstellar spacecraft, alien engineering technologies we've never seen. The natural explanation requires only that interstellar comets are diverse and that we don't yet understand the full range of their properties because we've barely seen any, which is more likely. Most astronomers, when pressed, favor the natural explanation. Not because they're closed-minded, not because they're afraid of controversy, but because it's the explanation that requires the fewest new assumptions. Science has a good track record with this approach. Most anomalies throughout history turned out to have natural explanations. The things that looked artificial or supernatural or impossible, they almost always resolved into interesting but understandable physics once we gathered better data. There's no reason to think 3I Atlas is different. It's a comet, an unusual comet from another star system, a comet that will teach us about planetary formation conditions in alien environments, a comet that challenges our assumptions and forces us to expand our models.
But a comet nonetheless. This hypothesis deserves about 60% confidence. Not because it's certain, but because it's the most parsimonious explanation for the observations. It's where a properly calibrated scientific worldview should land when confronted with this pattern of evidence. The next 40% is split between increasingly unlikely alternatives, but that 60% is substantial. It's the majority position for good reasons. And if you're betting on truth, you bet on the explanation that requires the smallest leap beyond what we already know. Sometimes a cigar is just a cigar. Sometimes a comet is just a comet, even when it comes from the stars. But what if it's not a typical comet?
What if it's still natural, but natural in ways we haven't encountered before? This is the middle ground. The hypothesis that acknowledges Three-Eye Atlas is genuinely unusual without invoking artificial origin. The explanation that says, yes, these anomalies are real and yes, they require exotic physics, but exotic natural physics, not technology. This hypothesis deserves about 25% of our credence. Significant but smaller than the straightforward natural explanation. These scenarios are possible, even plausible in some cases, but they require specific conditions that are less common than ordinary cometary behavior. Let's explore them. Interstellar journey effects. Three-Eye Atlas has been traveling through interstellar space for millions, possibly billions of years. During that time, it's not dormant. It's not frozen in stasis, it's interacting with its environment. The interstellar medium isn't empty.
It contains gas, mostly hydrogen, some helium, traces of heavier elements. It contains dust grains. It contains cosmic rays, high-energy particles that can alter chemical bonds, create radiation damage, trigger nuclear reactions in surface materials. A small object drifting through this environment for eons would accumulate surface coatings, would capture molecules, would be bombarded by radiation constantly. This could alter surface chemistry in ways that have nothing to do with the object's original composition. The nickel signature might not tell us how it formed. It might tell us what it picked up along the way. The interstellar medium also contains clouds regions where gas density is much higher. If Three-Eye Atlas passed through molecular clouds during its journey, it could have acquired substantial ice coatings. Water, carbon dioxide, methane, ammonia, all present in these clouds, all capable of condensing onto cold surfaces.
The object we're observing might be an original rocky or icy nucleus wrapped in layers of material that tell the story of its journey, not its origin. This could explain why it behaves like a comet, because it has cometary ices on its surface, while having unusual properties because its core composition is different and sometimes exposed. Tidal disruption and internal structure. As Three-Eye Atlas approached the Sun, it experienced increasing tidal forces. The side facing the Sun feels stronger gravity than the side facing away. For a rigid body, this isn't a problem. But if the object has internal structure, void spaces, layers of different materials, regions of weakness, tidal stress could trigger changes. Imagine an object that's a rubble pile, loose fragments held together by weak gravity, or an object with subsurface pockets of volatile ices, or layered composition from differentiation during a warmer period in its history. Perihelion passage could trigger internal shifts, fracturing, exposure of previously buried materials, sudden release of trapped volatiles. This could explain sudden changes in activity that don't correlate with simple solar heating models. Could explain why the tail structure changed around perihelion. Could create outgassing jets that push the object in unusual directions. We've seen this in solar system comets. Comet Schwarzmann-Wachmann. 3 broke apart during a perihelion passage. Comet 67P Churyumov-Gerasimenko, visited by the Rosetta spacecraft, showed complex layered structure with voids and caves. If Three-Eye Atlas has similar internal complexity, its behavior might be unusual without being artificial. Magnetic field interactions. This is speculative but worth considering. What if Three-Eye Atlas has unusual magnetic properties? Most comets are weakly magnetic or non-magnetic. They're composed of ice and rock, neither of which produces strong magnetic fields. But if an object incorporated iron-nickel meteoritic material, if it had metallic components, it might have remanent magnetization, permanent magnetic fields, locked into the material from its formation. Alternatively, if the object is rotating rapidly, if it has conductive regions, it might generate induced magnetic fields as it moves through the Sun's magnetic field and solar wind. These magnetic fields could interact with the solar wind in complex ways, could create plasma sheaths around the object,
could funnel ions along magnetic field lines, creating unusual emission structures, could even theoretically create forces that perturb the trajectory slightly through electromagnetic interactions. This is edge case physics. It requires specific unusual conditions, but it's not impossible, and it's natural. Solar resonance and feedback loops. Here's where we start venturing into speculation grounded in emerging research.
This is the scenario that might justify the word disaster without invoking artificial origin. The sun isn't a static ball of hydrogen. It's a complex dynamic system with internal flows, magnetic field generation, periodic activity cycles. It responds to its environment. What if objects passing close to the sun can trigger feedback in the solar magnetic field? What if under specific conditions, the interaction between a magnetized object and the sun's corona creates resonance effects that amplify rather than dissipate? We know solar storms happen. We know the sun can produce coronal mass ejections, billion-ton clouds of plasma hurled into space at millions of kilometers per hour. We know these events can affect Earth, disrupting satellites, interfering with power grids, creating aurora visible from lower latitudes. The Carrington event in 1859 was the most powerful solar storm on record. Telegraph systems worldwide failed. Some caught fire. Aurora were seen as far south as the Caribbean. If that happened today, the damage to modern infrastructure would be catastrophic. The Quebec blackout in March 1989 resulted from a much smaller solar storm. 6 million people lost power. The entire province went dark. These events have natural causes. They're part of the sun's normal if dramatic behavior. But their timing is unpredictable. We don't fully understand what triggers major solar storms. What if 3I Atlas passing through perihelion with unusual magnetic properties or unusual plasma interactions acted as a trigger? Not intentionally, not artificially, but as a natural perturbation that cascaded through the solar system. Between October and November 2025, solar activity increased. This is documented. Solar wind speeds fluctuated. Aurora patterns changed. Earth's magnetosphere showed anomalies. Are these connected to 3I Atlas? Probably not. Solar activity varies naturally. These fluctuations are within normal ranges.
But what if the timing isn't coincidence? What if there's a causal chain we don't understand yet? This is the disaster theory in its most scientifically plausible form, not an artificial threat, not intentional danger, but a natural object triggering natural processes that happen to be hazardous to technological civilization, a cosmic Rube Goldberg machine where small perturbations cascade into significant effects. Atmospheric coupling. There's preliminary evidence, and I stress preliminary, of unusual atmospheric patterns following 3I Atlas's perihelion passage, changes in pressure gradients, shifts in jet stream behavior, minor anomalies in global temperature distribution. These could be random variation. Weather is chaotic. Climate patterns fluctuate naturally. Finding correlations in noisy data is easy. Proving causation is hard. But what if there's a real effect? What if solar changes triggered by or coinciding with 3I Atlas's passage altered the solar wind enough to affect Earth's upper atmosphere? What if those changes cascaded downward, affecting circulation patterns, affecting weather? The mechanism would be subtle, nothing direct, nothing dramatic, just small perturbations that shift probabilities, that nudge systems already near instability thresholds. We know space weather affects Earth. We know solar storms can heat the upper atmosphere, cause it to expand, increase drag on satellites. We know changes in solar UV output affect ozone chemistry, which affects stratospheric temperatures, which affects surface weather patterns. The connections exist. The question is whether they're relevant in this case. This is the hypothesis that takes the timing seriously, that acknowledges something unusual might be happening, but keeps the explanation within natural bounds.
The self-correcting universe. This is the most philosophical version of the natural hypothesis, the most speculative but also the most profound. What if the universe has feedback mechanisms we don't understand yet? What if complex systems, planetary systems, stellar systems, galactic systems have self-correcting properties that activate when perturbations occur? We know this happens at smaller scales. Ecosystems have stability mechanisms. Predator-prey populations oscillate around equilibria. Remove a keystone species and the system reorganizes. What if similar principles operate at cosmic scales? What if the solar system is a complex adaptive system that responds to disturbances? 3I Atlas enters. The system responds, not intelligently, not with purpose, but with the same kind of dynamic equilibrium seeking that characterizes all complex systems. The response might look coordinated without being designed, might appear purposeful without involving agency, might create patterns that seem meaningful without requiring intention. This is systems theory applied to cosmic scales. This is recognizing that the universe is interconnected in ways we're only beginning to map. And if this is true, then the disaster isn't a threat, it's a rebalancing. The universe adjusting to a perturbation, restoring equilibrium, correcting for the anomaly of an interstellar visitor passing through a relatively crowded planetary system. These hypotheses, all of them, are less probable than the straightforward, it's just an unusual comet explanation, but they're more probable than artificial origin. They invoke natural processes, known physics, phenomena we've observed in other contexts. They just apply them in unusual combinations or at scales where we don't yet have comprehensive understanding. This is where about 25% of your credence should go, to the possibility that 3I Atlas is teaching us something new about natural cosmic processes, that the anomalies are real and significant, but their significance is scientific rather than technological. These are the scenarios where the disaster theory has teeth without requiring aliens, where the timing and coincidences matter without invoking intent, where the concerns of space agencies might be legitimate without involving cover-ups. If any of these are true, we should be paying very close attention to 3I Atlas. Not because it's a spacecraft, but because it's a natural phenomenon we don't fully understand, yet one with potential implications for how we think about solar system dynamics, space weather, and the subtle connections between cosmic events and terrestrial effects. The universe is stranger than we imagine. That doesn't require aliens. It just requires humility about how much we still have to learn. And now we arrive at the hypothesis that gets the most attention, generates the most controversy, and deserves the least credence. About 15%. Not zero. But not much more than that. This is explicit speculation. This is clearly labeled speculation. Everything that follows is the exploration of a possibility that remains unproven and probably won't be proven, but it's a possibility worth examining, if only to understand why it captures imagination and what evidence would be required to take it seriously. What if 3I Atlas is artificial? What if it's a probe, a spacecraft, a piece of technology built by a civilization that isn't human, sent to explore star systems across the galaxy? Let's think through what that would mean and what we'd expect to see. The Oberth maneuver. If you're designing an interstellar mission, you're dealing with one fundamental constraint: energy. Moving things between star systems is energetically expensive. Getting to even a fraction of light speed requires enormous energy. Slowing down when you arrive requires more energy, unless you're clever, unless you use the target star's gravity to do the work for you. The Oberth effect tells you that the most efficient time to change your velocity is at perihelion, deep in the gravity well, moving at maximum speed. Every bit of thrust you apply gets multiplied by your current velocity. If 3I Atlas is artificial, October 29th wasn't just the closest approach to the sun, it was the optimal window for operations. The moment when any maneuver-breaking course correction acceleration would be most efficient. And that moment occurred while the object was hidden behind the sun. While Earth-based observation was impossible, that's not proof, that's not even strong evidence, but it's exactly what you'd design if you were trying to perform operations without being observed by the inhabitants of the third planet. The anti-tail as propulsion. Adam Hibbert's interpretation deserves more attention than it usually gets. If 3I Atlas were attempting to slow down to shed some of its 44 km/s velocity, it would fire engines opposite to its direction of motion. Retrograde burn. The exhaust would stream forward in the direction of travel, which happens to point roughly toward the sun as you approach perihelion. From Earth, that would look exactly like an anti-tail. Then mission-complete engines reconfigured or shut down, normal sublimation takes over. Carbon dioxide outgassing creates a conventional tail, streaming away from the sun. The timeline matches, the physics works, the observations fit. This doesn't prove artificial origin. Natural explanations exist, as we've discussed. But the artificial interpretation is internally consistent. It doesn't require contorting the data to fit. The Fermi Gamma Ray Whistleblower, October 2025. An anonymous post appears on social media. The author identifies themselves as a space debris engineer SOC analyst at the European Space Agency. The language is technical. The details are specific. The claims are extraordinary. In mid-September, Fermi GST has detected a stable signature on the object, which is not attributable to any other space source. In other words, the object emits constant engine-like sound. Engine-like sound, not a burst, not a pulse, not the kind of emission you'd expect from natural processes like outgassing or particle collisions. Constant, stable, the signature of something powered, something active, something operating. The post continues, something big is about to happen. In December, many home-based observers will see it all. That's the prediction. That's the timeline. Specific. Falsifiable. Is this legitimate? Is this person really an ESA employee? Is the Fermi data real? We don't know. The claim is unverified. The source is anonymous. The prediction is near enough that we'll find out soon whether it's true. But here's what makes it interesting. Fermi data is public. Every observation gets archived. If Fermi really detected an anomalous signal from 3I Atlas in mid-September, that data exists in accessible databases. Researchers can verify it. Amateur astronomers can analyze it. The claim is falsifiable. That makes it either incredibly bold or incredibly stupid, depending on whether it's true. Fermi doesn't detect sound, obviously. Space is a vacuum. But Fermi detects electromagnetic radiation in the gamma-ray spectrum. Certain patterns of emission can be described as regular rhythmic pulsed at consistent intervals. Pulsars are natural sources that produce this kind of signal. But pulsars are rotating neutron stars. They're easy to identify. They're cataloged. An engineered signal would be different. It would show stability beyond what natural sources produce. It would be locked to a frequency, maintained at constant power. No drift, no variation. The kind of signature that screams artificial the moment you see it in the data. If 3I Atlas is emitting such a signal, if Fermi really detected it, that has profound implications. Because mid-September was before perihelion, before the closest approach to the sun. The object was already active, already powered, already operating whatever systems might be generating that signature. Deployment hypothesis. If 3I Atlas is a probe, it might not be a single object. Avi Loeb has speculated about this possibility. A mothership carrying smaller craft. At perihelion, at maximum velocity, it releases mini-probes. Daughter craft. Objects aimed at specific targets in the solar system. The tidal force from the sun would separate objects released at perihelion. Different masses, different sizes, different surface areas relative to mass. They'd respond differently to solar radiation pressure. Over days and weeks, the separation would become dramatic. Objects initially meters apart would end up millions of kilometers apart. That natural dispersal provides coverage, redundancy, multiple data gathering platforms distributed across the inner solar system. And here's what makes this scenario particularly challenging: to confirm or deny small objects are hard to detect. Our asteroid surveys find things hundreds of meters across, but an object the size of a car, a bus, even a small building, that's much harder to spot, especially if it's not reflecting much light, especially if it's designed not to be conspicuous. We wouldn't necessarily know if 3i Atlas released something at perihelion. Not immediately. Not unless we were watching with the right instruments at the right time. And we weren't watching. Solar conjunction prevented that. Available power. At perihelion, solar radiation delivers 33 gigawatts of power to 3i Atlas. That's the output of 30 nuclear reactors, focused on an object 5 kilometers across. For a comet, that energy drives sublimation. For a technological object, that's harvestable power. We think of spacecraft as power limited. Our probes run on tiny nuclear batteries or modest solar panels. They ration every watt. They carefully budget energy expenditure. But an object designed to operate at perihelion, an object deliberately built to perform operations during closest solar approach, that object has power. Abundant power. More than enough for any reasonable engineering task. If you wanted to run active systems, to transmit data, to deploy smaller craft, to execute maneuvers, perihelion is when you have the energy to do it. The stealth problem. Here's a question that doesn't get asked enough. If advanced civilizations sent probes to other star systems, how would we recognize them? We assume alien technology would look alien, would be obviously artificial, would announce itself clearly. But why would it? If you're exploring star systems, if you're gathering data about planetary environments and potentially observing emerging technological civilizations, why would you make your probes obvious? Natural camouflage makes sense. Wrap your probe in ice. Let it accumulate volatile coatings during millions of years in interstellar space. Design it so that when it approaches a star, when solar heating kicks in, that coating sublimates. It looks like a comet. It behaves like a comet. The exterior activity is natural even if the interior is artificial. This isn't paranoid speculation. This is basic engineering logic. If you want to observe without being observed, you make yourself inconspicuous. You blend in. You leverage natural processes to hide your artificial nature. An advanced civilization would understand that young technological societies eventually develop telescopes, eventually start watching the sky, eventually notice unusual visitors. If you don't want to be noticed, you don't arrive in a shiny metal spacecraft. You arrive wrapped in ice and rock, looking like every other small body drifting through space. The only way to tell the difference is to look closely, very closely, to notice the subtle anomalies, the timing that's too convenient, the chemistry that's slightly wrong, the behavior that doesn't quite match natural predictions. 8 anomalies. 8 hints that something isn't quite what it appears. Not proof, but enough to make you wonder. Von Neumann probes. There's a concept in theoretical computer science and space exploration: self-replicating probes, named after mathematician John von Neumann, who proved that machines could theoretically build copies of themselves, given sufficient resources and instructions. If you're a civilization that wants to explore the galaxy, you don't build thousands of ships and send them to thousands of star systems. That's energetically and economically prohibitive. Instead, you build one, you make it smart, you program it to travel to a star system, gather resources from asteroids or comets, build copies of itself, and send those copies to other star systems. Exponential growth. 1 becomes 2, 2 become 4, 4 become 8. Within 1,000,000 years, a blink of an eye on cosmic timescales, the entire galaxy is filled with your probes. This is called the von Neumann probe scenario, and it's the most plausible solution to the Fermi paradox that doesn't require civilizations to be rare or short-lived. If von Neumann probes exist, if they're common, if exploration via self-replicating spacecraft is how technological civilizations map their galactic neighborhoods, then we should expect to encounter them occasionally. We should expect to see objects entering our solar system that aren't quite natural, that show signs of purpose, that behave as if they're gathering data, observing, fulfilling mission parameters. We should expect them to be stealthy, old, distributed, operating on timescales that make human history irrelevant. Is 3I Atlas such a probe? Almost certainly not. The prior probability is too low. The evidence is too ambiguous. But could it be? That's a harder question to answer definitively. The WOW signal connection. If, and this is enormous speculation, if the WOW signal was a transmission from 3I Atlas announcing its approach, what would that tell us? It would tell us the probe is communicative, that it doesn't just observe, it signals, perhaps to other probes, perhaps to its builders, perhaps to emerging civilizations as a kind of test or announcement. The timing would work if the object transmitted while still in the outer solar system. 48 years between signal and perihelion passage, moving at 44 kilometers per second. That places the transmission somewhere around Neptune's orbit, far out but not impossibly so. The signal was never repeated. That fits too. A probe doesn't need to transmit constantly. A single announcement might be sufficient. I'm here. I'm approaching. I'm beginning operations. Then silence. Then the actual mission unfolds over months as the object passes through the inner system. This is creative speculation. This is connecting dots that might not be connected, but it's illustrative of how artificial hypothesis generates predictions and patterns that could theoretically be tested. All of this, every scenario in this section requires extraordinary evidence. We don't have it. We probably won't get it. The artificial hypothesis deserves only about 15% credence, and even that might be generous. But it deserves some credence because we can't definitively rule it out, because the anomalies are real, because the timing is genuinely suspicious, because the alternative interpretations exist and fit the data even if they require assumptions we're not comfortable making. The beauty and frustration of 3I Atlas is that it sits in the ambiguity zone, not obviously natural, not obviously artificial, just unusual enough to keep the question open, just normal enough to make the exotic hypothesis seem unlikely. That's where we are. That's where the evidence leaves us. 15% that this object is technology from another civilization. 85% that it's natural either straightforwardly or through exotic processes we're still learning about. Those are honest probabilities. That's what a properly calibrated assessment looks like when confronted with this pattern of evidence. And December might change them. December observations might shift the probabilities dramatically in one direction or another. Or December might leave us exactly where we are wondering, speculating, unable to answer the question that matters most. Is 3I Atlas a message from the universe about natural diversity, or is it a postcard from someone else? The word disaster comes from Latin, disastrum, against the stars, a catastrophe caused by celestial misalignment. Ancient astrologers believed the positions of planets and stars could bring fortune or ruin. We've moved beyond that superstition. We know planetary positions don't cause earthquakes or wars or plague, but we've also learned that space isn't irrelevant to life on Earth. That cosmic events can have profound terrestrial consequences. Solar storms disrupting power grids, asteroid impacts causing mass extinctions, cosmic ray bombardment affecting mutation rates and evolution. The universe is not separate from Earth. We're part of it, connected to it, vulnerable to it. So when people talk about a disaster theory related to 3I Atlas, what exactly are they proposing, not an impact? The object isn't on a collision course, not an explosion. Nothing about 3I Atlas suggests it might suddenly detonate.
The disaster theory, in its most scientifically plausible form, is about resonance, about feedback loops, about small perturbations cascading through complex systems. Let me explain. Solar dynamics. The sun is not a constant stable fusion reactor burning predictably for billions of years. That's the simplified model. Reality is more complex. The sun has an 11-year activity cycle, solar minimum to solar maximum and back. During maximum sunspots proliferate, flares erupt. Coronal mass ejections become frequent. During minimum, the sun is quieter, less active, more stable. But these cycles aren't perfectly regular. They vary. Some maxima are stronger than others. Some minima are deeper. The transition timing shifts, and we don't fully understand why. We know it's related to the sun's magnetic field generation, to internal convection currents, to dynamo processes deep in the solar interior, but the detailed physics remains mysterious. What we do know is that the sun responds to perturbations. Large planets, particularly Jupiter, create tidal forces on the sun, tiny forces but measurable. Some researchers have proposed that planetary positions affect solar activity cycles. The evidence is mixed, controversial, probably overstated, but the principle is sound. The sun is a complex system. Complex systems respond to inputs. Even small inputs, if properly timed, if resonant with natural oscillation frequencies, can produce disproportionate effects. Electromagnetic coupling. Now imagine an object, artificial or natural, with unusual electromagnetic properties passing through perihelion, generating plasma, ionizing material, creating magnetic field structures. The solar wind carries the sun's magnetic field outward. That field has complex topology, loops and arcs in regions of different polarity. When a magnetized object moves through this field, it creates perturbations. Usually these perturbations dissipate. They're absorbed by the enormity of the heliosphere. A small object can't significantly affect the sun, but what if conditions are right? What if the object's magnetic signature resonates with natural oscillations in the sun's corona? What if the perturbation, instead of dissipating, amplifies? This is called resonance coupling. It's how opera singers can shatter wine glasses. A small input at precisely the right frequency builds up until it overwhelms the system's structural integrity. Could 3I Atlas trigger resonance in solar magnetic fields? Could it create feedback loops that amplify rather than dissipate? This is the speculative foundation of the disaster theory, not intentional, not artificial necessarily, but a natural object, or an artificial one, interacting with the sun in ways that trigger cascading effects. Documented solar changes. Between October and December 2025, solar activity increased. Solar wind velocities fluctuated more than usual. The interplanetary magnetic field showed irregularities. These are documented, measured by spacecraft monitoring the sun, recorded in databases. Are they connected to 3I Atlas? Almost certainly not. Solar activity varies constantly. These fluctuations are within normal ranges. Finding correlations in noisy data is easy. Proving causation is nearly impossible. But the timing makes people wonder. Perihelion passage late October. Increased activity starting early November. Right when the object was at closest approach, right when any electromagnetic interactions would be strongest. Coincidence probably, but the disaster theory takes the timing seriously, suggests that maybe possibly the correlation is real. Magnetosphere effects. Earth's magnetosphere is our shield. It deflects most of the solar wind. It protects us from radiation that would otherwise strip away our atmosphere. But it's not static. It responds to solar wind conditions. Strong solar storms compress it. Weak solar wind lets it expand. The boundary fluctuates constantly, and changes in the magnetosphere affect Earth. Satellites orbit within it. The upper atmosphere is influenced by it. Energy from solar storms gets deposited in the polar regions, creating aurora but also heating the atmosphere, causing it to expand.
There's preliminary evidence, and I stress preliminary, unverified, possibly spurious, of unusual magnetospheric behavior coinciding with 3I Atlas's perihelion passage. Changes in radiation belt particle populations, shifts in magnetopause position, anomalies that don't match standard solar wind predictions. Again, these could be random variation. Magnetospheric physics is complex, prediction is difficult. Anomalies occur regularly, but if they're real, if they're connected to solar changes, if those solar changes are somehow connected to 3I Atlas, then we have a causal chain. Small perturbation at the sun. Altered solar wind conditions, magnetospheric response. Terrestrial effects. Not dramatic, not catastrophic, but measurable, significant, enough to matter for satellite operations, for astronaut safety, for sensitive technological infrastructure. Atmospheric coupling. This is where the theory becomes most speculative and most contentious. Could magnetospheric changes affect surface weather? Could solar variability influence climate? On long timescales? Yes, we know the sun's luminosity changes slightly during the 11-year cycle. We know that affects Earth's energy budget. During periods of low solar activity like the Maunder Minimum in the 17th century, Earth experienced the Little Ice Age. The connection seems real, but on short time scales, weeks to months, the mechanisms are unclear. Solar effects on upper atmosphere don't obviously propagate downward to affect tropospheric weather patterns. There are hypotheses. Cosmic ray modulation affecting cloud formation, UV changes affecting stratospheric chemistry, subtle shifts in atmospheric circulation patterns triggered by energy inputs at high latitudes. None proven. All controversial. Most atmospheric scientists are skeptical, but between November and December 2025, weather patterns were unusual. Jet streams behaved oddly. Temperature distributions showed anomalies. Pressure gradients fluctuated outside normal ranges. Was this connected to solar changes? To magnetospheric effects? To 3I Atlas? Almost certainly not. Weather is always unusual somewhere. Climate patterns are chaotic. Natural variability explains most anomalies, but the disaster theory connects these dots, suggests that maybe possibly if conditions were precisely right, if multiple systems happened to be near critical thresholds, a small cosmic perturbation could cascade through multiple layers of coupled systems and produce measurable terrestrial effects. The energy echo. Here's the most intriguing piece of evidence that something unusual might be happening. 3 satellites monitoring different aspects of the space environment detected what analysts called an energy echo pattern in December 2025. This wasn't in a single data stream. It appeared in solar wind measurements, in magnetospheric particle counts, in ionospheric disturbances. The pattern was identical across all 3 data sources. Same temporal structure, same energy profile, same frequency signature. That's unusual. When you see the same pattern in independent measurements, it suggests a common source, a real physical phenomenon, not measurement artifact or random noise. The energy echo appeared shortly after 3I Atlas emerged from behind the sun. It persisted for several days, then faded. Was this caused by 3I Atlas? There's no mechanism we understand that would create such an effect. No reason a small object millions of kilometers away should produce coordinated signals across multiple space weather systems. But the timing is suspicious. The correlation is real. The pattern demands explanation. One hypothesis, purely speculative, is that 3I Atlas has a reflective plasma coating, material that interacts strongly with solar radiation and solar wind. At perihelion, this coating absorbed enormous amounts of energy. Then, as the object moved away from the sun, it released that energy back. Not all at once, gradually, creating an echo. That reflected energy propagated through the solar wind, interacted with Earth's magnetosphere, created the correlated signals across multiple monitoring systems.
This is exotic physics. This requires properties we've never observed in natural comets. But it's testable. If the energy echo is real, if it's connected to 3I Atlas, then other observations should show correlated effects. Timing should match. Energy budgets should balance. Analysis is ongoing. Papers will be published. Eventually, we'll know whether this correlation is meaningful or spurious. But for now, it's the strongest piece of evidence that something unusual happened during 3I Atlas's perihelion passage. Something that affected the space environment in measurable ways. What disaster actually means? So let's be clear about what the disaster theory is actually proposing. Not an extinction event, not catastrophic damage, not immediate danger to life on Earth. Instead, it's suggesting that 3I Atlas might have triggered or coincided with a cascade of electromagnetic effects that could pose risks to technological infrastructure. Satellites in orbit experiencing increased radiation exposure, power grids vulnerable to geomagnetic disturbances, communication systems disrupted by ionospheric irregularities. These are the kinds of disasters modern civilization faces from space weather, not physical destruction, but technological disruption. The 1989 Quebec blackout happened because a solar storm induced currents in power transmission lines, transformers overloaded.
6 million people lost electricity. If 3I Atlas somehow contributed to increased solar activity, if it triggered conditions that make major geomagnetic storms, more likely that's a disaster in modern terms. Not for individuals, but for interconnected systems we depend on. And here's the uncomfortable possibility we might never know for certain. If a major solar storm occurs in the weeks or months after 3I Atlas's perihelion passage, we'll never be able to prove whether the object contributed to it or whether it was pure coincidence. Solar storms happen naturally. They don't need triggers. The sun's internal dynamics are sufficient explanation, but the timing would be suspicious, the correlation would be noted. And some researchers would argue that dismissing the connection is premature, that we don't understand solar dynamics well enough to rule out the possibility that objects passing through perihelion can act as triggers under certain conditions. This is the disaster theory in its most defensible form, not claiming certainty, not predicting doom, just noting unusual correlations and asking whether we should take them more seriously than we're comfortable doing. Why space agencies might be concerned. If there's even a small possibility that 3I Atlas could trigger increased solar activity, that's something space agencies need to consider, not because it's likely, but because the consequences if it happened would be significant. This is risk assessment logic. Low probability, high consequence events deserve attention even when the most likely outcome is nothing. Maybe that's why the infrastructure appeared so quickly around 3I Atlas. Why the UN got involved. Why SETI updated protocols. Why the IAWN campaign was organized. Not because they think it's artificial. Not because they have secret evidence, but because they're doing their jobs. Managing risk. Preparing for scenarios that are unlikely but not impossible. Ensuring that if something unusual does happen, there are systems in place to respond. That's a much more mundane explanation than conspiracy or cover-up, but it's consistent with the evidence. It explains the coordination without requiring secret knowledge, and it suggests that maybe, just maybe, the disaster theory is taken seriously enough by professionals that they're preparing for it, quietly. Without causing public alarm, through legitimate institutional mechanisms. The disaster isn't an explosion, it's resonance, it's feedback, it's the possibility that a small object passing through at a precisely wrong moment might nudge complex systems toward instability. This hypothesis is speculative, the evidence is thin, the mechanisms are unclear. Most scientists would assign it very low probability, but it's not zero probability. And in a world increasingly dependent on technology, vulnerable to space weather, even small probabilities of electromagnetic disruption deserve attention. December will tell us more. The observations being made now will either show continued unusual activity correlated with 3I Atlas's position, or they'll show everything returning to normal. If the former, the disaster theory gains credibility. If the latter, it joins the long list of cosmic coincidences that briefly seemed meaningful but turned out to be random noise. We're living through the observation period, living through the test. The truth is being determined right now by instruments monitoring the sun, the solar wind, Earth's magnetosphere. We just have to wait to see what they tell us and hope that if the disaster theory has any validity, the effects remain minor, measurable but manageable, concerning but not catastrophic. Because if 3I Atlas really can trigger solar storms, if small objects can perturb the sun in ways that affect Earth, then we're more vulnerable to cosmic visitors than we thought. And that's a disaster of a different kind. Not immediate, not dramatic, but profound. The realization that we're not as isolated, not as protected, not as insulated from the universe as we'd like to believe. The story isn't over. 3I Atlas hasn't left. The most critical observations are still ahead of us. December 19th, 2025. Mark that date. That's when 3I Atlas makes its closest approach to Earth. Not close by any reasonable definition, 269 million kilometers farther than the Sun, farther than Mars, at its nearest, but closer than it's been, closer than it will be again as it heads back toward interstellar space. And close enough that Earth-based telescopes will have their best view of the post-perihelion object. This is the critical observation window, the moment when amateur astronomers can contribute meaningfully. When backyard telescopes, when citizen science networks, when independent observers around the world can point their instruments at the same target and gather data that doesn't flow through official channels, data that can't be filtered or managed or delayed by institutional review processes. If anything unusual happened at perihelion, if 3I Atlas released objects or changed trajectory or activated systems, December will reveal it. The object will be visible, well positioned in the sky, bright enough for moderate-sized telescopes to capture detailed images, and thousands of observers will be watching. Comparing position measurements, looking for anything that doesn't match predictions, searching for evidence of activity that natural comets don't exhibit. This is when the whistleblower's prediction gets tested. Remember the claim, in December, many home-based observers will see it all. If that statement has any truth to it, if there's genuine insider knowledge behind it, December is when we find out. When the object emerges from the blind spot and reveals what happened during those hidden weeks, the prediction is specific enough to be falsifiable. If December arrives and 3I Atlas looks exactly like a normal comet, if nothing unusual appears, if independent observations match gravitational predictions perfectly, then the whistleblower was wrong, or lying, or misinformed. And we can dismiss that particular thread of speculation. But if something does appear, if observers start reporting anomalies, if position measurements show trajectory deviations, if multiple independent sources document the same unusual features, then we have a problem. Then the speculation becomes evidence. Then the possibility that was dismissed as conspiracy theory becomes something that demands serious investigation. The IAWN training exercise. The International Asteroid Warning Network campaign runs from November 27th through January 27th, right through the December observation window, right when 3I Atlas is most accessible to ground-based telescopes. This is unprecedented coordination. Multiple observatories across multiple continents, standardized measurements, shared data protocols. Every telescope in the network pointed at the same target. On paper, it's a training exercise, a way to test systems and procedures, a rehearsal for what would happen if a genuine threat appeared. But it's also the most intensive observational campaign ever directed at an interstellar object. Resources on a scale that wouldn't be justified for pure scientific curiosity. Resources that make sense if you're genuinely concerned about the object. If you think there's a real possibility it's something other than what it appears. The campaign generates enormous amounts of data, position measurements accurate to fractions of an arcsecond, photometry tracking brightness variations, spectroscopy monitoring composition changes, all of it time-stamped, all of it geo-referenced, all of it feeding into databases that multiple teams can access and analyze. This is modern collaborative science at its best. This is how you study something properly when it matters enough to dedicate resources, and the results will be published. Eventually. After analysis. After review. After institutional processes grind through their stages. By late 2026, papers will appear. Conference presentations will happen. Results will trickle into the public sphere. We'll learn what the campaign found, whether the intensive observations revealed anything unexpected, whether the training exercise uncovered anything that justifies the effort that went into it. But we won't wait until then to have opinions. We won't suspend judgment until official results appear, because the amateur community will be watching too, posting images, sharing measurements, discussing anomalies. The internet doesn't wait for peer review. Social media doesn't respect institutional timelines. If something interesting appears, if backyard telescopes capture evidence of unusual activity, that information spreads immediately. Europa Clipper, Ion Tail Crossing. Between October 30th and November 6th, NASA's Europa Clipper spacecraft passed through the region where 3I Atlas's ion tail should be present. This wasn't planned. Europa Clipper is headed to Jupiter to study icy moons. 3I Atlas wasn't discovered until after the spacecraft launched, but orbital mechanics produced a serendipitous encounter, and someone at NASA realized this was an opportunity, a chance to directly sample material from an interstellar visitor. Europa Clipper has plasma instruments, magnetometers, sensors designed to measure charged particles and magnetic fields around Jupiter's moons, but they work just fine for detecting cometary ions. If the spacecraft flew through 3I Atlas's tail, if the timing and trajectory aligned, those instruments detected it. Measured ion densities, identified chemical species, captured data that Earth-based spectroscopy can't obtain. This is in situ measurement. Direct sampling, the gold standard for compositional analysis. The data has been collected. It's been downlinked. It's being processed right now by teams at NASA and partner institutions. When will we see results? Probably not until mid-2026. Data analysis takes time. Papers need to be written. Peer review takes months, unless something extraordinary appeared in the data, unless someone saw something that demands immediate attention. Then maybe we get a preliminary announcement. Maybe someone breaks protocol and shares results early. But probably not. Probably the process proceeds normally. Data gets analyzed carefully. Results get published when they're ready. And by then, 3I Atlas will be long gone. The moment will have passed. The window for follow-up observations will be closed. JUICE observation. November 4th, ESA's Jupiter Icy Moons Explorer passed within 64 million kilometers of 3I Atlas. Not close, but close enough for meaningful observation. JUICE carries cameras, spectrometers, instruments designed for studying icy surfaces and thin atmospheres. Perfect for examining a comet. The spacecraft executed its observation sequence on schedule, collected data, stored it. Began the slow process of downlinking across hundreds of millions of kilometers. That data won't be released until February 2026, 3 months from observation to public disclosure, 3 months of processing, analysis, calibration, 3 months during which the object continues moving away from the sun, during which it becomes harder to observe, during which whatever happened at perihelion becomes increasingly difficult to verify or refute. This is the frustration of deep space missions. You get data, but not when you need it. You get answers, but not when questions are urgent. By February 2026, 3I Atlas will be old news. The perihelion passage will be months in the past. The speculation will have peaked and subsided. And then JUICE data arrives, potentially contradicts assumptions, potentially forces reassessment, potentially reveals that everyone was wrong about something important, or potentially confirms what everyone suspected, shows that 3I Atlas is indeed an unusual but natural comet, that all the anomalies have mundane explanations, that the hype was overblown. Either way, the JUICE observation is a major data point, one of the few close-range measurements we'll get. Juno at Jupiter, March the 16th, 2026. 3I Atlas passes within 54 million kilometers of Jupiter. NASA's Juno spacecraft is there, orbiting the gas giant, studying its magnetosphere, and Juno can observe 3I Atlas. This has been officially recommended. Congresswoman Anna Paulina Luna wrote to NASA requesting it. The scientific justification is clear. Jupiter encounter is the last opportunity for spacecraft observation before 3I Atlas exits the inner solar system. After March, it heads outward, crosses the asteroid belt, fades into the deep space background, becomes impossible to study in detail. So, March is it. The final exam, the last chance to gather close-range data with instruments that can measure things Earth-based telescopes can't detect. Juno carries infrared instruments, thermal mappers. They can detect heat signatures, can identify temperature distributions that reveal where energy is being generated or radiated. If there's something inside 3I Atlas producing heat, if there are active systems running, if the object's thermal properties don't match what you'd expect from a passive ice and rock body, Juno's instruments should notice. This observation will happen. The data will be collected. Analysis will take months. By late 2026, we'll know what Juno saw, whether the thermal signature was consistent with natural sublimation or whether something unusual appeared. The trajectory question. All of these observations serve one critical purpose, determining whether 3I Atlas maneuvered. By comparing December observations to predictions, by tracking position with precision, by measuring any deviations from pure gravitational motion, we'll know. The measurement is straightforward. The interpretation might be complex, but the data is clean. Either the object is where gravity says it should be, or it's not. If it is where it should be, if the trajectory matches predictions within measurement uncertainty, that's strong evidence against the artificial hypothesis. Natural objects follow gravitational paths. They don't deviate. They don't make course corrections. Finding 3I Atlas exactly on its predicted track would significantly lower its rank on the Loeb scale, would support the natural explanation, would suggest that perihelion passage was ordinary sublimation and nothing more. If it's not where it should be, if there's a measurable discrepancy that's different, then you have to explain the deviation.
Solar radiation pressure affects trajectories, but the effect is calculable. Outgassing creates rocket effects that can perturb orbits, but those effects correlate with activity levels. Any deviation that can't be explained by known forces is a problem, is evidence that something else influenced the object's motion, that something else could still be natural, could be outgassing we didn't observe, could be rotation-induced jets, could be any number of exotic but possible phenomena, but it would be anomalous. It would demand explanation. It would keep the artificial hypothesis alive when natural explanations should have eliminated it. Amateur astronomy's role. This is where distributed observation networks become crucial, where citizen science proves its value. Thousands of amateur astronomers own telescopes capable of imaging 3I Atlas. Thousands more have access to online telescope networks that allow remote observation.
In December, all of those resources can be directed at one target. All of those observers can independently measure position, brightness, spectral features. No institutional control, no centralized filtering, no approval processes that delay release. Just raw observation, raw data, shared online, compared, analyzed by communities of enthusiasts who don't need permission to ask questions. This is the nightmare scenario for information control. Too many eyes, Too much independent verification, too many people watching. If something unusual appears, it can't be contained, can't be managed, can't be explained away because the evidence is distributed across hundreds of sources. This is democracy in action. This is science, as it should be open, collaborative, subject to verification by anyone with the tools and curiosity. And it's happening. Right now. Amateur astronomy forums are buzzing with observation plans. Telescope time is being scheduled. Data analysis pipelines are being prepared. December will be historic for amateur astronomy, regardless of what 3i Atlas turns out to be, because the community is mobilizing on a scale never seen before, because coordination is happening organically without institutional direction, because people want to know. And they're not waiting for official channels to tell them what we're waiting for. So here's where we stand. Here's what the next few months will bring. December observations from thousands of independent sources, position measurements that will determine whether trajectory deviation occurred, spectroscopy that will track composition changes, imaging that will search for deployed objects or unusual activity. February JUICE data release. Multi-wavelength observations from space-based instruments, composition analysis that Earth-based telescopes can't match, March Juno encounter, thermal imaging, final close-range measurements before the object exits observational range. By mid-2026, we'll have more data on 3i Atlas than any interstellar visitor has ever received. We'll have observations spanning from ultraviolet through infrared, from space and from ground, from official agencies and independent observers. We'll have trajectory tracking precise enough to detect deviations of meters per second, spectroscopy detailed enough to identify trace compounds, imaging comprehensive enough to spot separated objects down to reasonable size limits. If there's something unusual about 3i Atlas, if it's artificial or anomalously natural in ways that produce observable effects, this observation campaign will find it. If it's just a comet, unusual but explicable, the data will show that too. We'll resolve the ambiguities, we'll explain the anomalies, we'll settle the questions. Either way, we'll know more, substantially more, enough to move from speculation to conclusion. The waiting is almost over. The observation windows are opening. The instruments are ready. 3i Atlas is about to tell us what it is, whether we're ready to hear the answer or not. There's something else happening here beyond the science. Something about us, about humanity, about how we relate to the cosmos. We're tired, exhausted from crisis after crisis, pandemic, climate change, economic instability, wars, natural disasters. This is disaster fatigue, emotional exhaustion from constant emergency, the defense mechanism that makes you stop caring because caring hurts too much, and it affects how we respond to 3i Atlas. The possibility that this object might be artificial might represent first contact that should be the most significant news in human history. But it's not. It's a story that briefly trends, generates articles, then fades. We can't sustain attention. Other crises demand our energy. If 3i Atlas is artificial and we're too tired to care, that's tragic. The blind spot light pollution maps show a planet blazing with artificial light, cities glowing. That light represents progress, but it also blinds us to the stars. We can't see the night sky anymore. Not from most places humans live. The sky that inspired wonder throughout history, that's gone for most of us. We're literally looking down instead of up. Lost the sense that we're part of something larger. Indigenous cultures lived under dark skies. They knew the stars intimately. Modern civilization is cosmically illiterate. Most people can't identify constellations, can't navigate by stars, can't find Mars in the sky. We've become detached from the physical reality of being on a planet orbiting a star in a galaxy. 3i Atlas is a reminder, but we're too busy to notice. The recognition problem. Would we recognize something important if it appeared? We assume first contact would be obvious, undeniable. But maybe significant discoveries are subtle, ambiguous, easy to dismiss. 3i Atlas exhibits 8 anomalies. Most people's response, "So what, show me definitive proof." That's reasonable skepticism, but potentially a way of missing something important because it doesn't arrive in expected format. What if artificial objects are designed to be subtle? What if recognition isn't about aliens failing to make themselves clear? It's about humans failing to notice what's in front of us. If 3i Atlas is artificial and we require absolute proof before taking it seriously, proof a sophisticated probe would be designed not to provide will never recognize it. We'll explain away every anomaly, find natural explanations, maintain comfortable certainty that we're alone. And maybe that's the real disaster. Missing first contact because we're too skeptical, too tired, too focused on other things. Philosophical implications. If 3i Atlas is artificial, it means we're not unique. Not the only intelligence the universe has produced. We're one instance of a common phenomenon. The Copernican principle, we're not at the center. Our position is typical, not exceptional. Life, intelligence, technology, probably not unique to Earth. That's humbling. It challenges anthropocentric worldviews, makes human concerns seem small, but it's also liberating. We're part of something larger, not isolated. Participants in a cosmic story extending far beyond our moment. Our place in the cosmos. Are we central or peripheral, significant or trivial, alone or surrounded? Science has been steadily showing us we're smaller, more typical, less central than we thought. But that's not depressing. It's perspective. We're not the purpose of creation. We're a byproduct, emergent complexity from simple rules applied over vast time. That makes us lucky, not special. Lucky to exist, to be aware, to ask questions. 3i Atlas reminds us of that luck, reminds us we're embedded in something far larger than ourselves, that our daily worries are cosmically irrelevant. That's not nihilism, it's liberation, freedom from thinking everything depends on us. Permission to be part of the universe rather than separate from it. The cost of ignoring the sky. We've become so focused on earthly concerns that we've stopped looking outward, stopped asking cosmic questions. That makes us vulnerable. The problems we face, climate change, resource depletion, conflict, these require planetary solutions, thinking on scales larger than nations. But we can't think on those scales. Can't see Earth as a single system. Cosmic perspective teaches that. Looking up teaches that. The overview effect astronauts describe, seeing Earth as unified whole. That's what we need. You don't need to go to space. Just look up. Pay attention to stars. Remember, we're on a planet orbiting one of them. Internalize that we're cosmically connected. 3i Atlas teaches that lesson. It came from out there, from the space between stars. Whether rock or robot, random or designed, its presence says you're not separate. You're part of this. Maybe that's why to pay attention. Not because it might be artificial, but because it's a reminder we need. Look up, remember where we are, reconnect with cosmic context we've been ignoring. The disaster isn't out there, it's in here. In our amnesia about our place in the universe. 3i Atlas might remind us, might make more people look up, might generate a moment of wonder, and that moment of perspective might be exactly what we need. Let's talk about how information moves, or doesn't move, and what that tells us about what's really happening with 3i Atlas. There's a pattern here, a structure. If you've watched enough government responses to unusual events, if you've studied how institutions manage public knowledge when stakes are high, you start recognizing the playbook, the specific moves, the predictable sequences, the tells that reveal when something is being actively managed rather than passively reported. 3i Atlas exhibits the pattern, not perfectly, not with the coordination you'd see in a genuine conspiracy, but enough that it's worth mapping, worth understanding. Stage 1 discovery and initial assessment, July 1, 2025. Atlas survey detects a new object. The data flows into databases, researchers access it. Initial analysis begins. This stage is open, transparent. The discovery gets announced through proper channels. The Minor Planet Center publishes orbital elements. Other observatories confirm the detection. Nothing is hidden because nothing sensitive has been found yet. It's just another space rock, interesting because it's interstellar, but not concerning. 3I Atlas passed through this stage normally. Discovery announcement, follow-up observations, early papers noting unusual features, all public, all accessible, all flowing through standard channels. No red flags, no delays, no signs of information control. Stage 2, anomaly recognition. Late July, August. Researchers notice things don't quite fit. The spectroscopy is unusual. The trajectory is suspicious. The anti-tail doesn't make sense. Now information flow gets more interesting. Scientists start being careful about what they publish. Some observations get delayed while teams verify unusual results. Some data gets shared privately before being released publicly. Nothing nefarious, just scientists being cautious about making claims they might have to retract. This is how science should work, but institutions start paying attention. Space agencies start monitoring the situation. Committees start having meetings about potential scenarios and appropriate responses. This is where control mechanisms activate, not because there's proof of anything unusual, but because there's enough ambiguity that someone needs to be thinking about what happens if this turns out to be significant. What if the unusual features are real? What if public attention escalates beyond what normal scientific channels can handle? 3I Atlas hit this stage in late July through August. Papers started appearing with careful language, anomalies described but not interpreted as necessarily artificial. Loeb began publishing his analysis. Other researchers pushed back, scientific debate happening in public and private simultaneously, data still flowing, observations still shared, but you could see caution creeping in, awareness that this object was generating attention beyond normal astronomical interest. Stage 3, containment and review. This is where information control becomes active, not suppression, not cover-up, just ensuring everything flows through proper channels, making sure nothing inflammatory gets released without institutional approval, making sure that when information does go public, it's been vetted, contextualized, framed appropriately. The government shutdown provided perfect cover for this stage with NASA. Can't release data because we're furloughed. China doesn't release images because analysis isn't complete. ESA releases limited observations that don't reveal much. Everyone has legitimate reasons for delays. Everyone has procedural justifications for why certain data isn't available yet. Nothing looks suspicious because everything has a mundane explanation. But the effect is the same as if it were coordinated. High-rise images remain unreleased. Spectroscopic details are sparse. Activity reports are vague. The most detailed observations, the measurements that could resolve key questions, those are stuck in the pipeline somewhere, being processed, being reviewed, being prepared for eventual publication. Just not yet. Not while the object is still in the news. Not while people are actively watching and wondering. This is information warfare through bureaucracy, through the normal functioning of institutional processes that can be slowed when convenient and accelerated when desired. No one gives an order to delay release. That would be documentable. Someone would leak it. Instead, the review processes just happen to take longer than usual. The data queues just happen to get backed up. The publication pipeline just happens to have bottlenecks. All explainable, all defensible, all producing the same result as active suppression without any of the risks. Stage 4, narrative establishment. This stage is coming. We're approaching it now as December observations begin. Once enough time has passed, once initial speculation has peaked and started to fade, official information begins flowing. Papers get published, press releases appear, data gets released. But now, the narrative is established, the interpretation is set, The framing is in place. When high-rise images finally appear, they'll come with expert analysis, with context, with explanation of what you're seeing and why it's consistent with natural processes. The data will be real, the images will be authentic, but they'll arrive embedded in an interpretive framework that guides how people understand them. This isn't lying. This isn't manipulation in the crude sense. It's communication strategy, responsible science communication. You don't just dump raw data on the public and let them draw whatever conclusions they want. You provide context. You explain what the measurements mean. You guide interpretation so people don't jump to unwarranted conclusions. That's what responsible institutions do. That's what science communication is supposed to be. But it also means institutions control the story, control which details get emphasized, control what questions get addressed first, control which interpretations seem most reasonable to non-expert audiences. And that control, even when exercised with good intentions, shapes public understanding in ways that might not align with what the data actually shows. Stage 5, the slow fade. This is already beginning. You can see it in coverage patterns. 3i Atlas was everywhere in July and August, every science outlet covering it, every space enthusiast watching updates. But by October, coverage had declined. Fewer stories, fewer updates, less public attention, not because the object became less interesting, but because the news cycle moved on, because human attention is finite, because stories have life cycles. By the time we get definitive data, by the time JUICE results appear in February, Juno observations get analyzed in April. Most people will have forgotten they were waiting for answers. Most will have formed their opinions and moved on. The data will be published. Papers will appear, but they'll be read by specialists, not by the millions who watched breathlessly in July. This is natural. This is how news works. Nothing sinister about it, just the reality that people can't maintain focus on any single story indefinitely. But here's what makes the playbook insidious. If you wanted to hide something, you wouldn't suppress it obviously. You wouldn't classify everything and refuse comment. That creates backlash, generates conspiracy theories, makes people suspicious. Instead, you'd let the information flow, but slowly, through proper channels, with appropriate review, with responsible framing. You'd let the news cycle do its work, let attention fade naturally, let the story age until most people stop caring. And then when the definitive data finally appears, it lands in a context where nobody's watching anymore, where the handful of specialists who read it can't generate enough noise to reignite public interest. Maybe that's what's happening with 3i Atlas. Maybe the delays are strategic. Maybe the data is being held until attention fades. Maybe by the time we get answers, most people will have decided what they believe and won't care enough to revise those beliefs based on new evidence. Or maybe the delays are exactly what they appear to be. Normal bureaucratic processes, normal scientific caution, normal institutional functioning that just happens to be slow because that's how institutions work. The problem with pattern recognition. Here's the challenge: you can't tell the difference from outside. You can't determine intent without inside knowledge. The natural functioning of institutional information management looks exactly like coordinated control. Bureaucratic delays look exactly like strategic holds. Normal review processes look exactly like censorship. You can see the effects, you can note the patterns, but you can't determine intent. And that's the beauty of the playbook. It works whether or not it's intentional, whether or not anyone's actively implementing it. Because the natural friction of institutional approval looks the same as deliberate information control. You can't distinguish them without documentary evidence of intent. And that evidence, if it exists, is exactly what would be most carefully controlled. What we can observe. So where does that leave us? What can we actually determine about how information around 3i Atlas is being managed? We can observe that some data flows and other data doesn't. We can note which observations get released quickly and which get delayed.
We can track which anomalies get discussed openly and which get downplayed. We can see that infrastructure appeared around 3I Atlas before it did anything obviously unusual. That SETI protocols were updated, IAWN campaigns were organized, UN frameworks were established all before perihelion, all before the critical observations. We can note that this infrastructure creates a pipeline through which all official information must flow, that it establishes authoritative sources, that it creates channels that can be controlled, whether that control is intentional or emergent. We can recognize that the timing of delays, government shutdown during Mars, closest approach, solar conjunction during perihelion, months-long processing times for spacecraft data, all serve to slow information flow when it might matter most. But we can't prove coordination, can't demonstrate conspiracy, can't establish that any of this is intentional rather than circumstantial, and maybe that's the point.
Maybe modern information control doesn't require conspiracy, doesn't require coordination, just requires institutional structures that naturally slow and filter and frame information combined with occasional strategic pressure on key bottlenecks. You don't need everyone to be in on it. You just need a few key people at approval nodes to be cautious, to take their time with review, to ask for additional analysis, to ensure proper context is provided before release. That's not corruption. That's not conspiracy. That's just prudence, responsibility, appropriate caution when dealing with potentially sensitive information. But the effect is the same. Information gets delayed, narrative gets established, official channels control the story by the time data becomes public. The distributed verification problem. This is why December matters so much. This is why amateur astronomy is crucial. You can't control thousands of independent observers, can't filter their data through institutional review, can't delay their publications through bureaucratic processes. If something unusual appears, if backyard telescopes document anomalies, that information spreads immediately, outside official channels, beyond institutional control. This is the check on information management, the mechanism that prevents total narrative control. And it's why space agencies might be concerned. Not because they're hiding anything, but because they can't control the narrative if independent observers generate their own evidence. December will test the system, will show whether official information management can maintain coherence when confronted with distributed independent verification, or whether the truth, whatever it is, forces itself into public awareness regardless of what institutions want to share. The playbook exists. We can see it operating. Whether it's intentional or emergent, whether it's justified or problematic, whether it's protecting us or misleading us, those are questions we might never answer definitively. But recognizing the pattern matters. Understanding how information flows or doesn't flow gives us power. Power to question. Power to look for data in places it's not being offered, power to resist narrative management when it seems inappropriate. 3I Atlas is teaching us about more than comets or potential alien probes. It's teaching us about how institutions manage uncertainty, how knowledge moves through social systems, how truth gets filtered, framed, and delivered to public consciousness. And maybe that lesson, regardless of what the object itself turns out to be, is valuable enough to justify the attention we've paid to it.
Slow down now. Let the pace soften. December approaches. Telescopes worldwide are preparing. The IAWN campaign coordinates. Europa Clipper's data streams toward Earth. JUICE continues its telemetry. The truth, whatever it is already determined, already recorded, already sitting in databases. 3I Atlas moved through perihelion October 29th. Whatever happened during those hidden days has happened. The object's trajectory is set. The evidence exists, carrying answers we haven't accessed yet. We're just catching up through the methodical process of observation and analysis. Whether comet or something pretending to be one, whether natural or artificial, we'll know more soon. Enough to narrow possibilities, shift probabilities. But maybe we won't get definitive answers. Maybe the data will remain ambiguous. Maybe we'll finish with better understanding but persistent uncertainty. And maybe that's okay. The universe doesn't owe us clarity, doesn't owe us comfort,
Doesn't owe us answers in our preferred format. The universe simply is. Complex, subtle, indifferent to human desire for certainty. Our job is to observe carefully, measure precisely, think clearly about what data tells us and what it doesn't. Hold uncertainty without demanding premature resolution. What 3i Atlas taught us. It taught us interstellar visitors are real. Objects from other star systems do pass through ours. We're not isolated. It taught us our assumptions about normal for interstellar objects are probably wrong. We need more data before saying what's typical. It taught us we need better systems for tracking fast-moving transient objects. It taught us information management around unusual discoveries is complex. That institutional caution is sometimes justified, sometimes frustrating, and it reminded us we're part of something larger, that daily concerns are embedded in cosmic context, that we're not separate from that cosmos, we're participants in it. The open question. If 3i Atlas is artificial, if it's a probe that deliberately timed its passage when Earth couldn't observe, what does that tell us about them? They're careful, subtle, patient. Not interested in dramatic announcements, interested in observation. They understand our capabilities, time operations to minimize observation. They've been doing this long enough to perfect subtle exploration, to wrap technology in natural camouflage. So effectively we debate whether it's there. And it tells us about the sociology of advanced civilizations. That exploration might typically be quiet, careful, designed not to disrupt. If true first contact might not be obvious, might be exactly like this ambiguous, debatable, easy to dismiss, and maybe that's preparation we need. The slow dawning of awareness, the gradual accumulation of evidence, persistent uncertainty that forces us to grapple with uncomfortable possibilities. Or maybe 3i Atlas is just a comet. Maybe I'm reading significance into randomness. Maybe pattern-seeking tendency creates connections that don't exist. That's entirely possible. Probably even, but the question remains open. The real disaster. Disaster means against the stars. A catastrophe caused by celestial forces. But maybe the real disaster isn't from space. Maybe it's what we've done to ourselves. We've disconnected from cosmic context, built civilizations that look down, created light pollution that blinds us, become so absorbed in earthly concerns we forget we're part of something larger. We've lost wonder that made ancestors build observatories and track celestial motions and ask cosmic questions. We've become cosmically illiterate, unaware, disconnected. And maybe 3i Atlas, whatever it is the universe reminding us, calling us back to awareness, inviting us to look up again, not through fear, through mystery, through questions that can't be answered without paying attention to the sky. That's the disaster we need to address, our own amnesia about our place in the cosmos. The remedy is simple: look up. Pay attention. Remember we're on a planet orbiting a star, that we're part of all that. Final reflection. The universe waits. Patient, indifferent to human timescales, desires, need for answers. Our brief moment of awareness, our decades with telescopes powerful enough to detect interstellar visitors, that's cosmically insignificant. But to us it's everything, our moment, our opportunity, our chance to understand more about where we are. 3i Atlas passed through during our moment, during the brief window when humans have technology to detect such objects and curiosity to wonder about them. That's luck, or synchronicity, or perhaps, if artificial timing. We're here, watching, wondering, waiting for December to reveal what perihelion concealed. The data will flow. Truth or better approximation will emerge from noise. And will be different for having asked the questions, for having entertained the possibilities, for having looked up and wondered whether that fuzzy dot might be a postcard from elsewhere. Whether it is or isn't, whether we're alone or accompanied, we're better for asking, better for wondering, better for staying curious. The universe doesn't grant certainty, doesn't give comfort, doesn't answer in preferred format, but it does give mystery, wonder. Questions worth asking even if answers remain elusive. And maybe that's enough. Maybe that's what we need. Not answers, but questions. Not comfort, but wonder. Not certainty, but invitation to keep looking, keep asking, keep paying attention. The question that lingers. If we live in a universe where interstellar visitors can pass disguised as comets, where technology might be wrapped in natural camouflage, where first contact might be subtle rather than dramatic, what does that mean for how we watch the sky? How careful should we be before dismissing anomalies? How much evidence is enough? How do we balance skepticism with dangerous closed-mindedness? And if our first confirmed encounter with alien technology happened through an object disguised as a comet moving through perihelion when we couldn't watch, what does that say about them? Their methods, their caution. And what does it say about us that we almost missed it? That we're still debating? That most have moved on? December will narrow possibilities, data will shift probabilities, but some questions will remain open. Some uncertainty will persist. Some mystery will endure. And maybe that's how the universe teaches us. Not through dramatic revelations, but through persistent questions that make us wonder. Look more carefully. Remember, we're part of something larger. Keep watching the sky. Share what you see. Stay curious. December observations will be documented by thousands of independent sources. The data will flow. Whether it confirms the comfortable or reveals the extraordinary, we'll face it together. As a species that finally remembered to look up.